All right, everyone, grab your coffee, gather round, and let's get this morning huddle started. I'll be your instructor for this session, and look, I've been walking these exact same job sites, boots on the ground, for over 15 years now. I've seen the good, I've seen the bad, and man, I have seen the truly ugly when it comes to construction safety. So consider this explainer just like our daily morning safety briefing. The information we're covering in Module 1 of our OSHA 30-hour construction safety masterclass isn't just about checking some compliance box for the front office. It's the literal foundation of how we operate day in and day out there in the dirt.
So, before we dive into the weeds, I want you to ask yourself, why are we really here today? Seriously, answer that honestly in your head right now. I know a lot of folks think they're just sitting through this to get a little piece of plastic for their wallet, right? Just something to flash to the gate guard to get on site. But let me break it down for you real quick. We're here to make sure you and the crew working right next to you stay alive. That's the bottom line. This is absolutely not about bureaucracy. It's about making sure every single person who clocks in at dawn actually gets to clock out and go home to their families in one piece.
Okay, here's our morning safety briefing checklist. First, the reality of the job site. Second, the Wild West before OSHA. Third, how OSHA operates today. Fourth, your OSHA 30 roadmap. And finally, number 5, why this training matters. Moving right into Section 1, the reality of the job site. Let's start by busting the absolute biggest myth I hear out on the site. You'll hear guys strutting around saying, "I've got my OSHA certification, I'm licensed." Well, let's get the facts straight right off the bat. An OSHA card is definitely not a formal professional license. The fact is, it's officially a student course completion card issued by the Department of Labor. What it actually proves is that you have a solid baseline of safety awareness. It doesn't make you bulletproof, and it certainly doesn't replace the specific hazard-focused compliance training that your employer still owes you for your specific tasks. It just means you've learned how to spot a hazard before it takes someone's livelihood away. Oh, and by the way, thinking about showing up with a fake card, that will literally end your shift before it even begins. You'll be permanently barred from the job site. No questions asked. Section 2, the Wild West before OSHA. Look, to truly respect the rules, you kind of have to understand why they were written in the first place. See, we used to operate in the absolute dark ages of construction. For decades leading up to 1970, it was essentially the Wild West out there. We're talking incredibly high fatalities, staggering injury rates, and absolutely zero standard blueprints for keeping workers safe. It was a mess. Then, finally, in 1970, the OSHA Act was signed into law. This established the General Duty Clause, which meant, for the first time, employers legally had to provide a workplace free from recognized hazards. Shortly after, by April 1971, OSHA was officially established to actually enforce these standards. So when you see a safety role, remember, these regulations aren't just bureaucratic red tape. They are quite literally written in blood, designed to stop unnecessary deaths. And the impact of that massive change? It's completely undeniable. Back in 1972, right after this started, there were 10.9 incidents of worker injuries and illnesses for every 100 workers. 10.9. Fast forward to 2023, and that number has plummeted down to just 2.4 per 100 workers. That right there is hard proof that this system actually works. And remember, that difference in the numbers, we aren't just talking about statistics. Those are real, living, breathing people who didn't lose a limb, who didn't suffer a career-ending fall, and who didn't lose their lives. Which brings us to Section 3, how OSHA operates today. I get asked this all the time. What actually puts an OSHA inspector in a hard hat on our job site? Well, there are 4 main triggers. First up, imminent hazards. If an inspector is just driving by and sees an active trench without any shoring or a guy up on a roof without fall protection, yeah, they are pulling over and stopping work. Second, accident investigations. If a serious injury happens, you better believe they're coming out to figure out exactly why. Third, direct worker complaints. If folks report unsafe conditions, OSHA investigates. And fourth, planned, programmed inspections. OSHA actively targets high-risk sectors, stuff like construction, roofing, and excavations, to perform proactive, unannounced audits.
So what happens when a site decides to ignore the rules? The costs of non-compliance escalate incredibly fast. Step 1, it starts with site audits and inspections, which cause major operational disruptions. Everything grinds to a halt. Step 2, you get hit with citations and public reputational damage. Companies known for poor safety records, they lose clients and they lose bids. Then, step 3, we hit the wallet. Fines can be up to $10,000 or even $20,000 for multiple offenses. And finally, step 4. If there is a willful violation that results in a worker's death, or if someone decides to provide false information to an inspector, you are looking at criminal charges and potentially up to a year in jail. This is serious, serious business. Let me give you a quick pro tip straight from my years in the field. Federal OSHA sets the baseline, sure, but many states have their own federally approved safety plans. States like New York, Massachusetts, Connecticut, and a bunch of others frequently mandate this 10-hour or 30-hour training on their public works projects. What this means is local laws and project contracts can hit you with requirements that are even stricter than the federal baseline. If you don't know your local turf, you can literally be denied job site access and your entire project can grind to a halt. Let's look ahead. Section 4. Your OSHA 30 Roadmap. What exactly are you going to get out of the rest of this masterclass? Well, we are going to spend a huge chunk of our time, at least 6 hours, on the absolute heavy hitters. We call these the Focus 4 because they are the leading causes of death in construction. We're talking falls, think unprotected edges, sketchy scaffolding or ladders, electrocution from overhead power lines or missing GFCIs, struck by incidents, which involve falling tools or getting hit by heavy machinery like cranes and trucks, and caught in or between hazards, like deadly trench collapses or unguarded machinery. As supervisors and leaders, your head needs to be on a swivel for these 4 specific hazards at all times. But we don't stop at the Focus 4. This masterclass is specifically designed to shift you from a worker mindset directly into a supervisor mindset. We'll be diving deep in how to manage complete safety and health programs. We'll cover the proper use of personal protective equipment and long-term health hazards, things you might not feel today, like respirable crystalline silica and noise exposure. We'll go over the strict standards for stairways and ladders, how to safely navigate tricky excavations and confined spaces, and the absolute right way to handle hand and power tools. This is advanced hazard recognition designed to make you a true safety leader on your site. Section 5. Why this training matters. Why does dedicating 30 hours of your life to this material actually matter to you personally? Ultimately, taking this course seriously is what separates a rookie from a highly respected site leader. It's about protecting your crew. It drastically reduces job site incidents. It builds a much stronger safety culture where everyone is speaking the exact same language. For your career, it builds your credibility and actively prepares you for leadership roles like foreman, superintendent, or safety coordinator. But above all else, it gives you the practical tools to ensure that when the whistle blows at the end of the day, everyone clocks out in one piece. So, developing a daily blueprint for survival on the site isn't about memorizing the exact subpart of some dusty regulation. No way. It's about developing a gut instinct for hazard recognition. It's about completely shifting your mindset so that when you're looking at a shaky scaffold or a frayed power cord tomorrow morning, you instantly know how to react and correct it before something goes wrong. That is what this entire training is geared toward. But knowing the rules of the job site is really only half the battle. Understanding your rights is the rest of the equation. So I want to leave you with a quick challenge. How are you going to turn these hundreds of pages of OSHA rules into a highly practical daily blueprint for survival on your site? Start thinking about it. Because next up, we're rolling straight into Module 2 to unpack exactly what the law guarantees you. Keep those hard hats on, and let's keep moving. All right, so wrapping up the history of the OSHA Act from our last session, we saw exactly how the agency came to be and why it was so desperately needed. But here's the thing. The OSHA Act didn't just create a bunch of thick rulebooks to sit on a dusty shelf in the GC's job trailer. No, it created a literal, personal shield for every single worker on the job site. I've been doing this for over 15 years, and I can tell you firsthand that knowing how to use this shield changes everything. Let's look at exactly what it's made of. This is OSHA's rights and responsibilities. Here's the tailgate whiteboard plan for this one. 1. Your core safety rights. 2. The right to know. 3. Whistleblowers and speaking up. And 4. Employer safety responsibilities. All right, Section 1. Your core safety rights. Listen, I want you to keep something in the back of your mind as we go through this list. These are not suggestions. They aren't favors your employer's doing for you because they're in a good mood. These are federal laws. First and foremost, you have the absolute right to a workplace free from serious recognized hazards. You also have the right to receive training in a language and vocabulary you actually understand. If you're out there exposed to toxic substances or heavy noise, you've got the right to access your medical and exposure records. You can even ask to review the OSHA Form 300 logs. That's the official record of injuries and illnesses on your site. We're talking total transparency here. And finally, you have the right to required personal protective equipment. Your safety gear is a legal right, not a luxury. Moving on to Section 2, the right to know. So, here is the harsh reality of construction.
You cannot stay safe if you don't know what you're working with. And that is especially true when it comes to invisible hazards like chemical fumes and toxic dust. This brings us to hazard communication, which we usually just call the right to know law. Basically, your employer must inform you about chemical hazards. This means there has to be proper, clear labeling on every single container. And you must have open access to the safety data sheets, that big SDS binder in the trailer, whenever you need it. If you're working with a new concrete curing compound or a harsh solvent, your defense starts with your right to know exactly what's in that bucket and how to protect your lungs and your skin.
Grab your highlighters for this exam tip, folks. Safety training must be in a language and vocabulary you understand. This is a massive deal out in the field. Think about it. If a contractor hands a highly technical 50-page English safety manual to a crew that primarily speaks Spanish, or they use a bunch of academic engineering terms with guys who just need the practical steps, that employer is completely failing their OSHA obligation. If the training doesn't connect, it flat out doesn't count.
And hey, remember, you're never alone out there. Free safety and compliance assistance is always available through official resources like OSHA.gov. If the safety info on your job site is lacking, or you just need to verify a standard for yourself, OSHA is there as your backup. You absolutely have the right to ask them for help. Let's look at Section 3, Whistleblowers and Speaking Up. We're shifting focus now from just knowing your rights to actually exercising them in the real world. Now, I know the fear out there. I've heard it a million times. Guys worry, if I speak up, am I going to get fired? Am I going to get blacklisted from other jobs? To understand exactly how the law protects you, we first have to define something called imminent danger. This is a situation where workers face an immediate risk of death or serious physical harm. Make no mistake, this is OSHA's #1 inspection priority. It is the trigger for taking immediate life-saving action. The crucial point here is knowing exactly how to handle that imminent danger when it's staring you in the face. Let's look at a real job site scenario. Let's say a foreman tells you to get down into a 12-foot trench. There's no shoring, no trench box, no sloping, nothing. You know it could collapse and bury you at any second. Here is the 4-step legal progression you follow to refuse that unsafe work and stay fully protected under the law. 1. Tell the employer or your supervisor about the hazard and ask them to fix it. 2. Make sure a reasonable person would agree a real danger of death or serious harm exists, which, for an unprotected trench, absolutely applies. 3. There is simply no time to call OSHA and wait around for an inspector to show up. 4. You stand down and refuse to work until it's made safe. If you follow those 4 steps, you are legally shielded. And that leads us perfectly to Section 11C of the OSHA Act. Here's a pro tip. Section 11C is the Whistleblower Protection Clause. This is the law that makes retaliation strictly illegal. If you report an injury, if you ask for safety gear, or if you refuse to jump into that unprotected trench, your employer cannot legally fire you, demote you, cut your hours, or transfer you to some miserable detail as punishment. But I need you to listen to me on this next exam tip, because it's also a real-world survival tip. You have exactly 30 days to file an OSHA whistleblower complaint. The clock starts ticking the very moment the retaliation happens. Do not wait. If you wait till day 31 to report that you are fired for speaking up about safety, you lose your federal protection under this specific statute. Time is of the essence. Let's dispel a very common job site myth while we're at it. Myth. You have to expose your identity to file an OSHA complaint and put a massive target on your own back. Fact, if you call 1-800-321-OSHA, your complaint can remain completely confidential. OSHA is not going to call up your boss and tell them who made the call. You can even have an authorized representative, like a union steward or a family member, file it on your behalf. All right, moving to Section 4, Employer Safety Responsibilities. We're going to pivot this masterclass now from the worker over to the employer. We've talked about your rights. Now let's set up the framework of accountability that the boss has to operate under. And it all starts with Section 5A1 of the OSHA Act. It says, and I quote, "Each employer shall furnish to each of his employees employment and a place of employment which are free from recognized hazards that are causing or are likely to cause death or serious physical harm." We call this the General Duty Clause. And guys, it carries incredible weight. Here's a pro tip on how that actually works. The General Duty Clause is OSHA's ultimate trump card. Sometimes there isn't a highly specific OSHA standard for a brand new hazard. Maybe it's a completely new type of machinery or a new building material. But that doesn't mean the boss is off the hook. If a hazard is recognized by the industry and it's dangerous, the employer must fix it. Period. There are no loopholes allowed just because a specific rule wasn't written for it yet.
So what does that look like day to day for the folks running the site? Here's the employer's non-negotiable duty checklist. They must actively find and correct problems before you get hurt. They must display the official OSHA poster where everybody can easily see it. They've got to provide medical exams when the standards require it. They must use color codes and labels to warn of hazards. And importantly, they must supply required PPE, like your fall protection harness, your hard hat, and your safety glasses, at no cost to you. I'll say it again, you should not be spending your own paycheck buying your own mandatory safety gear.
Also, safety is a continuing requirement. If an employer gets cited by OSHA for a violation, they can't just pay a fine, sweep it under the rug, and ignore the problem. They have strict abatement duties. That means they actually have to physically fix the hazard by a specific deadline set by the inspector, and they have to post proof that they did it for the whole crew to see. And when the absolute worst happens on a site, employers have strict reporting deadlines. Hammer this exempt tip home right now. Employers must report any work-related fatality to OSHA within 8 hours. If there is an inpatient hospitalization, an amputation, or the loss of an eye, they have exactly 24 hours to report it. Lock those numbers in your brain right now because you will see them again. 8 hours for fatalities, 24 hours for severe injuries. Now, I know what some of you are thinking. Hey, I work on a massive commercial site with 20 different subcontractors. Who is actually the employer responsible for my safety? It gets confusing, right? Well, OSHA handles this with what's called the multi-employer citation policy. On a complex site, responsibility is actually shared across 4 different employer roles. Let's break down exactly who gets the citation for what. First, the creating employer. They cause the hazard, like a sub who removes a guardrail and just leaves it. They get cited, even if it's not their own guys who end up falling. Then you have the exposing employer. That's the one whose workers are in danger. They have to protect their crew, no matter who made the mess. Third is the correcting employer. They're officially hired to fix hazards, like a scaffolding maintenance company. Finally, you have the controlling employer. This is the one with general supervisory authority, usually your general contractor. The GC must exercise reasonable care to detect and prevent violations across the entire site. They can't just shrug and turn a blind eye to a subcontractor's mess. To summarize this whole core message of empowerment, remember this exam tip. Your active participation is the core element of a successful safety culture. The OSH Act, the General Duty Clause, the whistleblower protections, all these federal rules only work if you know your rights, if you hold employers to their legal accountability, and if you look out for your crew. At the end of the day, you are the final line of defense. So now that you know exactly what your rights are and you have the full power of federal law behind you to speak up and refuse dangerous work, what exactly should you be looking out for? What are the top 4 deadliest hazards waiting for you on the construction site right now? Keep your hard hats on because we are going to break down the absolute biggest killers in Module 3.
All right, so you've just wrapped up your rights and responsibilities on the job site. You know that you have a fundamental, legally protected right to a safe workplace, but let's be real for a second. That right is constantly under attack the absolute second you step onto a job site. It's threatened by 4 very specific, very lethal dangers. We call them the OSHA Focus 4 hazards, and honestly, recognizing these 4 threats is the most important thing we are going to do together. This is where the rubber meets the road.
I want you to really think about that number, 598. I want that number to completely burn into your memory, because if we, as an entire industry, could just figure out how to eliminate the 4 specific hazards we're about to cover, we would save a minimum of 598 construction workers' lives every single year. These aren't just dry statistics in an OSHA manual. These are brothers, sisters, fathers, and friends who packed their lunch, went to work, and didn't make it home at the end of their shift. Recognizing these hazards early, before things go wrong, is the absolute most critical skill you can ever learn.
Okay, let's break down the actual data. When we look at the numbers from the Bureau of Labor Statistics, it paints a pretty clear picture. Out of 1,075 fatal injuries in construction back in 2023, you can see massive, unavoidable spikes. The Focus 4, which are falls, struck by incidents, electrocutions, and caught in or caught between incidents, they account for roughly 60% of all those fatalities. They are the undisputed heavyweights of job site dangers, period.
And leading that pack, as you just saw, is hazard number 1, falls to a lower level.
I need to be completely straight with you on this one. Falls are the undisputed #1 killer in the construction industry. They cause roughly 40% of our industry's fatalities. Nearly half of all fatal falls in the entire private sector happen to folks doing exactly what we do. It is our biggest enemy out there. And the scary thing? It happens fast, and it almost always happens when guys get a little too comfortable and complacent. Listen to this actual OSHA fatal fact. A worker carrying a sheet of plywood on a flat roof stepped into a skylight opening and fell to the level below. Just like that. Done. It's not always someone doing crazy high-wire structural steel work, right? Sometimes it's literally just stepping blindly backwards, or carrying a load that blocks your vision for 2 seconds near an unprotected floor hole, a leading edge, or a skylight.
So how do we actually stay alive? Here are your pro tips for fall prevention. First off, if you're on a ladder, you maintain 3 points of contact at all times. 2 feet in a hand, 2 hands in a foot. No exceptions. Second, if you're using a portable ladder to access another level, that ladder needs to extend 3 feet above your landing surface so you actually have something to grab onto when you're stepping off. Third, never get on a scaffold unless it has been explicitly inspected by a competent person. And lastly, you have to know when you need guardrails, safety nets, or personal fall arrest systems. Recognizing exactly what setup you need before you even start working, that's everything.
Let's move right along to hazard number 2, struck by incidents.
Now these hazards are distinctly different from your standard slips, trips, and falls. With a struck-by incident, the injury is caused purely by forcible contact or impact. Basically, something hits you, and the impact itself is what does the damage. There are 4 main ways this happens on a site, and we see them every day. Flying objects, like an accidental nail gun discharge or a saw blade kicking back a piece of wood. Falling objects, like a guy 2 floors up dropping his framing hammer, or a catastrophic rigging failure on a crane. Swinging objects, like an excavator boom turning just a little too fast, or a suspended load catching the wind and swaying into you. And rolling objects, like a vehicle backing up when you're standing in its blind spot, or some unsecured pipes rolling off a stack. You literally have to keep your head on a swivel out there.
To prevent getting struck, you absolutely must make yourself visible. Step 1. Always wear your high-visibility clothing. Do not be the guy blending into the dirt and shadows around heavy machinery. Step 2. Never position yourself between moving and fixed objects. That's a deadly pinch point waiting to happen. And step 3. Stay completely out of a crane or excavator swing radius. If you cannot look up and see the operator's eyes, trust me, they definitely cannot see you.
That brings us right to hazard number 3, caught in or caught between.
Now, I know a ton of guys out on the site get this one confused with struck by incidents. They sound very similar, but OSHA treats them completely differently, and understanding that difference is crucial for spotting the actual hazard before it gets you. So here is a massive exam tip for you. Pay close attention. The technical difference hinges entirely on the type of force. If the impact alone causes the injury, like a cinder block dropping directly onto your hard hat, that is a struck by. But if the injury is the result of a crushing force between 2 objects, like getting your hand literally pulled into a machine or getting pinned between a backing dump truck and a concrete loading dock, that is a caught in or caught between event.
The reality of caught-in hazards is frankly pretty grisly. Take a look at this real OSHA report. A worker was ripping a 6-inch piece of wood on an unguarded compound miter saw. His left thumb was caught in the saw and amputated. This is exactly why machine safety guards exist. Guys, if you pull a guard off a tool to make a job go just a little bit faster, you are literally putting your fingers, your hands, or even your life on the line. It is never worth the saved 5 minutes. Your pro tips for caught-in prevention start with a big one: trenches. Never enter an unprotected trench that is 5 feet or deeper. A trench cave-in is a classic caught-in hazard, and listen to me, dirt is incredibly heavy and totally unforgiving. A single cubic yard of soil can weigh as much as a mid-sized car. Let that sink in. Next, ensure all machinery safety guards are securely in place before you pull the trigger. Avoid wearing loose clothing, unzipped jackets, or dangling jewelry that can get snagged in moving parts. And stay highly aware of any equipment pinch points around you.
Let's shift gears to our final focus for hazard: electrocution.
First off, I need to clear up a massive misconception right now. You absolutely do not have to be an electrician to get killed by electricity on a job site. In fact, over 70% of the workers killed by electrical hazards are not electricians. They're laborers, painters, roofers, and heavy equipment operators. Consider this really tragic OSHA fatal fact. A 40-year-old plumber died after simply lying on his work light while crawling under a house. The wire inside the conduit had become bare. It energized the entire metal housing of the light, and because no GFCI was used, the current went straight through him to the ground. A simple, everyday tool turned lethal just because basic, simple safety measures were skipped. Because of stories like that, your electrical safety pro tips are completely non-negotiable. First, always locate overhead and underground utilities before you start digging or moving big equipment.
Second, inspect all your extension cords, plugs, and tools every single day before your shift starts. Look for frays, missing grounding prongs, or cracked housings. And third, always use a ground fault circuit interrupter, or GFCI. It's pure life-saving magic. If the current goes anywhere it shouldn't go, like say through your body, the GFCI senses that imbalance and cuts the power in a fraction of a second.
We've covered a ton of crucial ground today on the Focus 4, but before we wrap up, I want to leave you with a question to chew on. Do you know the exact height that triggers mandatory fall protection on your specific construction job site? Think about it, because falls are the absolute #1 killer in our industry. They demand our full, undivided attention. That is why they require their very own dedicated deep dive. Keep that question in the back of your mind, because we are going to break it all down and get you those answers in Module 4. Let's keep moving. Coming straight off those Focus 4 hazards we just wrapped up, we are zeroing in immediately on the absolute deadliest hazard on our job sites, and that's falls. Now, as an instructor who's been walking construction sites for over 15 years, I can tell you straight up that mastering OSHA's Subpart M is literally what determines whether you and your crew go home to your families at the end of the shift. So, let's get focused. 39%. Just let that sink in for a second. Falls caused 39% of construction fatalities in 2023. We're talking about 421 workers who lost their lives to a lower-level fall in a single year. That's more than a third of all construction deaths coming from this one hazard alone. And man, the heartbreaking truth, the thing that honestly keeps guys like me up at night, is that every single one of those fatalities was 100% preventable. Look, gravity never takes a day off. Never. But with the right systems in place, we can beat it every single time. All right, let's start with the baseline rule of the job site. When exactly do you need to tie off or set up protection? In Subpart M, we call this the trigger height. Whenever you have an unprotected side or edge, a leading edge, or a hole in your walking or working surface, OSHA requires you to be protected if that drop is 6 feet or more to the lower level. That's your magic number right there, 6 feet. Now here is a massive exam tip for you, and a pro tip for the field, because this trips up so many folks. In the construction industry, our trigger height is 6 feet. But if you cross over into general industry, say you're doing some work inside a manufacturing plant or a warehouse, under OSHA Standard 1910, that trigger height actually drops to 4 feet. And just to round the whole thing out, if you ever find yourself in a shipyard, it's 5 feet. But for our purposes right here in construction, burn that 6-foot rule into your brain so you don't get them mixed up on the exam or worse, out on the site. Okay, so let's take a walk around the site and look at the edge. Our very first line of defense is what we call passive protection. We call it passive because once it's installed correctly, you don't have to put on any gear or actively do a single thing to be protected by it. It's just there doing its job. And the most common passive protection system we use is the good old guardrail. But OSHA requires some really precise engineering for these rails. You gotta memorize these numbers for the test, and honestly, for your daily site walks. Your top rail must be exactly 42 inches high, give or take 3 inches. Why? Because that perfectly hits the center of gravity for most adults, which keeps you from doing a front flip right off the deck. Furthermore, that top rail has to be able to take 200 pounds of outward or downward force without snapping or failing. Think about a heavy worker stumbling and just crashing down onto that rail, it has to hold. Then your mid-rail sits halfway up, around 21 inches, and that one has to withstand 150 pounds of force. Now here's a common, really dangerous mistake I see out in the field all the time, using steel or plastic banding for top rails. Guys, OSHA strictly forbids this. Your rails have got to be surfaced smoothly to prevent you from getting a nasty puncture, a laceration, or snagging your clothing or your harness. And hey, if you're using wire rope for your top rail, which is super common, it must be flagged every 6 feet with high visibility material. Otherwise, somebody's going to walk right into an invisible wire, and trust me, that is not a good day. But look, sometimes slapping up a wooden or steel guardrail just isn't practical. Think about complex bridge work, or maybe structural steel erection where your leading edge is constantly moving. When rails just aren't feasible, we move to our next passive system, safety nets. Nets are absolute lifesavers, but only if they're rigged right. First rule, they can't be more than 30 feet below your working surface. And we don't just hang them up and hope for the best, nope. I've actually made crews entirely redo their rigging, because before you ever step foot over a net, it must pass a rigorous drop test right on the site using a 400-pound sandbag. I always tell my guys, I would way rather watch a bag of sand break a badly rigged net than watch one of you test it out.
Also, the mesh holes in the net can never be larger than 6 by 6 inches, and the heavy border rope holding the whole shebang together must have a minimum breaking strength of 5,000 pounds.
Okay, so what if we can't use guardrails and we can't string up safety nets? Well, then we have to rely on active protection. This is your personal fall arrest system, or PFAS. It's active because you have to consciously inspect it, physically put it on, and actively hook it up. This is the life-saving gear you're actually wearing on your body. Every personal fall arrest system has 3 non-negotiable parts. A lot of guys remember this as the ABCs of fall protection. A is for your solid anchor point, B is for your full body harness, and C is for your connector, which is the lanyard or lifeline that actually ties your harness to the anchor. It's really simple. If any one of these 3 components is missing or if it's damaged, the system will fail. And if the system fails, so do you.
I really want to highlight a crucial right way versus wrong way scenario here. Some of the older guys might remember a time when we used body belts. Let me be clear. Today, body belts are strictly banned for fall arrest. Why? Because the physics of a fall are completely brutal. If you fall while wearing a belt around your waist, all that sudden arresting force concentrates right on your lower back. It will literally shatter your spine and cause severe, life-threatening internal organ damage. You absolutely must use a full-body harness to evenly distribute that massive impact across your shoulders, your chest, your pelvis, and your thighs.
Speaking of impact, we need to talk about your anchor point. Your anchor isn't just any random piece of PVC pipe, some decorative railing, or standard roof vent. No way. OSHA mandates that an anchor point must hold 5,000 pounds of force per worker tied off to it. Think about that for a second. That is roughly the weight of a heavy-duty pickup truck. So if you and a buddy are both tied off to the exact same anchor, that anchor needs to be able to hold 10,000 pounds.
Now, that extreme anchor strength is 100% necessary because gravity generates an insane amount of force. But what about your body? Even with a properly rated shock-absorbing lanyard or deceleration device, your full-body harness is designed to limit the maximum arresting force hitting your body to 1,800 pounds. Without that shock absorber, the sudden stop at the end of the line would cause lethal trauma.
So, here's a real-world scenario where folks get hurt all the time. Failing to calculate fall clearance. Before you even hook up, you absolutely must do the math to make sure you won't hit the ground. Let's calculate it together. You take your lanyard length, say 6 feet, then you add your deceleration distance, which is a maximum of 3.5 feet as that shock absorber rips open, then add your height, let's say you're 6 feet tall, and finally, you always add a 3-foot safety factor. Add all that up, you need 18.5 feet of clearance. Think about it. If you tie off to an anchor at your feet on a 12-foot deck, you are going to hit the ground hard before your lanyard ever fully deploys. You've got to do the math.
But here's the thing. Having the right harness and doing all that math means absolutely nothing if your gear is shredded or if you don't have a plan for what happens after the fall. Stopping the fall is really only half the battle. Surviving the aftermath is the other half.
You have to inspect your gear before every single use. Not just on Mondays, not just once a month. Every time you put it on. Look for frayed webbing, burnt fibers, or D-rings that look bent or deformed. Yank any defective equipment out of service immediately. Seriously, cut it up right there so nobody else uses it by mistake. And finally, OSHA mandates that your employer must provide a prompt rescue plan. If you're left hanging in a harness, something called suspension trauma can cause blood to pool in your legs, and that can become fatal in a matter of minutes. Your crew has got to know exactly how to get you down fast.
All right, let's bring it all home. Falls are the #1 killer in our industry. But the main takeaway from this explainer today is that you have the power to change that on your site. Utilizing proper guardrails, ensuring your nets are actually tested, calculating your fall distances, and properly inspecting your PFAS every single time ensures that you will go home to your family tonight. Don't take shortcuts with gravity, guys. You won't win. So, you've learned to respect the edge. You know how to calculate your clearance, and you're fully protected from the drop. But as you safely stand up from securing that perimeter and look away from the floor, what invisible, deadly hazard is humming right above your head? Keep looking up, because we are tackling electrocution and electrical safety next. Let's keep moving.
All right, you've got your fall protection dialed in from Module 4, so you know how to keep from falling off the steel. But now, we've got to talk about the hazard you can't even see. Electrocution is our next OSHA Focus 4 topic, and we're jumping straight into the invisible dangers of electricity. There are no warning signs, no loud noises. It's completely silent. And let me tell you, in my 15 years out here on the site, I've seen it demand absolute respect from every single trade. Let's get to it.
Look at that number, 907. Between 2011 and 2023, there were 907 construction electrical fatalities. Really let that sink in for a second. That proves electricity is an invisible killer that absolutely does not give you a second chance. It's not like a missing guardrail or an unprotected trench that you can spot from clear across the yard. It is quiet, it is incredibly fast, and if you don't know exactly what to look for, you won't even realize it's a hazard until it's too late.
So, how do we spot an invisible threat? OSHA uses the acronym BSFE, and here's a quick exam tip for you. Memorize this one. We're talking about burns, electrocution, shock, arc flash or blast, fire, and explosions. Because it's not just about getting a nasty shock, right? It's about severe thermal burns from an arc flash or an explosion ignited by a tiny spark in a room full of combustible dust. By actively running through BSF during your morning walk around, you're literally training your eyes to spot the risks before anyone gets hurt.
Now, grounding is your absolute primary defense out here. Think of electricity exactly like water in a pipe. It's always under pressure, and it is always looking for the easiest, lowest resistance path right into the dirt. Proper grounding just ensures that if there's a leak or a short in that power tool you're holding, the path to the ground goes through a designated copper wire and not straight through your heart.
OSHA makes a massive distinction here, and a really common mistake I see out in the field is guys letting their egos get them hurt. A qualified person has highly specific, rigorous training to test and troubleshoot energized parts. Meanwhile, an unqualified person, which honestly is most of us on the site, the carpenters, the laborers, the operators, is not allowed to touch live parts, period. If you aren't the trained electrician, you keep your hands completely out of the panel. No exceptions.
Section 1. Look up overhead power lines.
Let's start our virtual job site walkthrough by literally just looking up at the sky. Overhead power lines are massive physical hazards for crane operators, scaffolders, or anyone just carrying a conductive ladder. It is way too easy to get tunnel vision on the task right in front of you and completely forget about what's 15 feet above your head. So if you're operating a lull or carrying a piece of aluminum strut across the yard, you need to know exactly what the minimum clearance distance is to stay alive. This is not a guessing game.
Remember this number, 10. For voltages to ground at 50 kilovolts or below, your absolute minimum approach distance is 10 feet, and you have to add an extra 4 inches for every 10 kV above that. I always tell my crews, draw an imaginary 10-foot bubble around those overhead lines and treat it like a solid brick wall. Electricity can arc right through the air. You don't even have to physically touch the wire to get electrocuted if you breach that boundary. Now, even if you are a qualified employee, Table S5 dictates strict approach limits. Notice how you have to avoid contact entirely under 300 volts and keep at least a 1-foot clearance up to 750 volts, scaling up as the voltage rises. This just goes to show that even the pros, the men and women with the highest level of electrical training, do not mess around with these approach boundaries. Respecting the boundary is exactly what ensures you make it to the dinner table at the end of your shift.
Section 2. Down to the ground. GFCIs and temporary power.
Okay, let's bring our eyes back down to the ground, because this is where day-to-day complacency really creeps in. You must use approved GFCIs on all 120-volt, 15 and 20-amp temporary receptacles on the site. Why? Because these little devices trip in a fraction of a second. A GFCI is looking for a tiny imbalance. We're talking just 5 milliamps. If it senses that juice going through your wet boots instead of the cord, it cuts the power in 1/40th of a second. That is faster than your heart can go into fibrillation. It's a literal lifesaver.
But a really common mistake I see on almost every job site is daisy-chaining extension cords, or treating them like permanent wiring. Look, we've all seen a guy wrap a torn cord in electrical tape, shrug, and just call it good. That is a massive hazard. You've got to inspect your cords daily. If you see a missing ground prong or cut insulation showing exposed wires, do everybody on site a favor. Cut the end off, tag it, and throw it straight in the trash so no one else picks it up.
Here is a pro tip straight from the field. Never stack drywall, tools, or your lunch cooler in front of an electrical panel. OSHA requires a strict 36-inch clearance so we can easily access those breakers in a true emergency. I see it all the time. A guy needs a quick place to lean his material, and the panel looks convenient. But if your buddy is getting locked up by a shock on the other side of the room, you do not have the time to move a heavy stack of 2x4s. Keep that 36-inch space completely clear every single day.
Section 3. Inside the panel.
Lockout, tag out, also known as LOTO.
When it's actually time to service or repair that equipment, we have to strictly follow lockout/tagout procedures. Think of this as your personal lifeline when you are elbows deep in a machine. You must follow these steps in the exact order. Identify the source, shut down the power, physically apply your specific lock and tag, and most importantly, verify it's totally dead. Remember, your lock is your life. You apply it, you take it off. Nobody else touches it.
And that verification step, it is not optional. A qualified person has to use a properly rated multimeter to test the circuit. Please remember this. You must treat every single wire as live until you have personally proven that it is dead. Never just trust that the breaker did its job or that the guy before you wired the switch right. Test before you touch. It literally takes an extra 10 seconds and it guarantees you get to go home tonight.
Also, don't make the rookie mistake of thinking that a regular, flimsy plastic handle on a cheap screwdriver from the hardware store is going to save you from a massive arc flash. It won't. If you are authorized to work near exposed energized parts, you absolutely must use certified IEC 900 insulated tools and the right arc-rated PPE. Real insulated tools are tested to 1,000 volts and they're clearly marked. Use the right tool for the job, not just whatever happens to be rattling around in the bottom of your bucket.
I want you to remember this quote, because your daily goal on the job site is to ensure your body never becomes the easiest path to the dirt. That is the core of all electrical safety. If you take the time to inspect your tools, actually use your GFCIs, honor those approach clearances, and practice proper lockout/tagout, you are actively keeping yourself out of the circuit.
So now you know how to lock out the invisible dangers of electricity. But out on the site, you still have to keep your head on a swivel. Because we are moving straight into Module 6, where we're going to tackle struck-by hazards. Electricity is perfectly silent, sure, but a swinging crane block or a backing dump truck? That's loud, heavy, and it could be coming right at you. So ask yourself this before we jump in. If you can master the hazards you can't even see, how sharp are your instincts going to be when the danger is staring you right in the face? Let's keep this momentum going and find out.
All right, we just locked down the invisible, silent dangers of electricity. You know, you can't see an electrical current coming before it gets you. But what we're looking at right now, oh, you can definitely see it coming. And it hits with brutal kinetic force. We're talking about struck-by hazards. If you've spent even a week on a job site, you already know the sounds, right? The heavy thuds, the screeching brakes, the crashing steel. That's a sound of our next focus. Now, while electricity zaps you and messes with your internal systems, a struck-by hazard is all about pure, unforgiving physics. If you've been on a site, you know exactly that feeling of the ground vibrating when heavy machinery rolls by. It literally rattles your boots. We're talking about the sudden transfer of kinetic energy from an object or a piece of equipment directly into your body. Whether it's a dropped wrench from 3 stories up, a swinging steel beam, or a forklift just throwing it in reverse, the outcome is that sudden, forcible impact. It's physics in action, and frankly, the human body just isn't built to absorb that kind of energy transfer. 75%. I want you to really notice that number. That is the massive percentage of struck-by fatalities on construction sites that involve heavy equipment. We're talking your dump trucks, cranes, excavators, forklifts. From the absolute second you step foot on the dirt, you are sharing space with massive steel machines moving massive amounts of material. The life or death stakes are real the exact second you clock in, and you've got to keep your head on a swivel. I always tell my crews, you have to treat every piece of heavy machinery like it's an apex predator, and you're stepping right into its territory. So, what exactly is it? Well, here's your official OSHA definition for the exam. A struck-by hazard is defined as forcible contact or impact between a person and an object or piece of equipment. Now, as someone who's been kicking around job sites for over 15 years, I'll tell you that's really just a fancy regulatory way of saying something heavy moved really fast and hit you hard. It's the hammer slipping out of a sweaty hand or that unshocked pipe rolling down a grade. It's forcible contact. And the thing is, it's entirely preventable if we train our eyes to see it before it happens. Here's our roadmap for mastering this hazard. 1. The 4 danger zones. 2. Real job site scenarios. 3. Defending your head. And 4. Pro tips and exam prep. Section 1. The 4 danger zones. Struck-by incidents are a massive part of OSHA's Fatal 4, which are the 4 deadliest hazards in construction. And OSHA actually categorizes them into these 4 distinct types. First, flying objects. Think of a piece of a shattered grinding wheel or a nail from a pneumatic gun flying through the air. Second, falling objects. That's a hammer dropped off a scaffold, maybe a loose brick slipping off a parapet. Third, swinging objects,
like a massive crane load twisting in the wind on a breezy Tuesday afternoon. And fourth, rolling objects, which usually means moving vehicles or unsecured pipes rolling down an incline. Every single one of these involves a totally different kind of movement, which means they require completely different safety habits to defeat.
Section 2. Real job site scenarios. Let's test your hazard recognition right here. What's the danger we're looking at? Notice the forklift transporting materials, and look really closely at what's strapped onto the forks. Those are unsecured gas cylinders. I remember a job about 8 years ago down in Texas. We had a guy transporting cylinders just like this. He hit a deep rut in the mud, the forklift bounced, and those pressurized cylinders didn't just become falling objects, they became deadly, unguided flying projectiles. I mean, one sheared its valve off and launched across the site like a torpedo, literally taking out a cinder block wall. Securing your materials before transport isn't just a suggestion, guys. It's an absolute necessity. You either secure it or it becomes a missile. Now here's a classic, everyday scenario for you. Workers using powder-actuated or pneumatic nail guns. Remember that kinetic energy equation from high school physics class? Energy equals 1/2 mass times velocity squared. The math tells us it's not the mass of the nail that kills you, it's the blistering speed. One of the absolute most common, fatal mistakes I see on job sites is guys rushing to frame out a room, firing a nail gun into easily penetrated materials, like plywood or gypsum board, when another worker is standing right on the exact other side of that wall. I've seen guys get tagged in the shoulder just because their buddy didn't check the blind side of the partition. Those fasteners will shoot straight through. You must always, always know what is behind the surface you're shooting into. Take a look at this suspended crane load hovering over a sidewalk area. The golden rule of hoisting, folks, is that you never, ever position yourself under a suspended load. Period. End of story. Because if the rigging fails, gravity takes over instantly, and you are not going to have time to react. Furthermore, to prevent that load from turning into a massive swinging hazard that sweeps workers right off the deck, you've got to use taglines. You guide a load from a safe distance using a tagline, never by grabbing the load with your bare hands. I don't care how heavy you think it is, a ton of swinging steel is going to win that wrestling match every single time. All right, let's talk about rolling hazards. Remember that statistic from a few minutes ago? 1 in 4 struck by deaths involves vehicles. Heavy machinery has massive blind spots. An operator inside an excavator or a dump truck simply cannot see you if you're walking right behind them. And this is exactly why we establish strict exclusion zones around mobile equipment. It's why we require spotters who maintain strict eye contact with the operator. If you can't see the operator's eyes in their mirrors, trust me, they cannot see you. It's also why newer white noise backup alarms and radar sensors are becoming standard, replacing those old single-tone beeps that just kind of blend into the background noise of a busy site. Oh, and if you're parking equipment on a grade, you chalk those wheels. Gravity never takes a day off. Section 3. Defending your head. For decades, the traditional hard hat was the undisputed king of the job site. But the science of head injuries has really advanced, and OSHA issued a major bulletin in late 2023 strongly encouraging a switch. Notice the comparison here. Traditional hard hats give you great top impact protection. I mean, they're great if a bolt falls straight down on your dome. But they do very little if you get hit from the side by a swinging pipe, and even worse, they easily fly right off your head if you trip or slip. Modern safety helmets, on the other hand, are specifically designed to dissipate side impact forces. They have chin straps so the helmet stays securely on your head where it belongs during a fall, and they allow for modular eye and face protection. Honestly, it's a total game changer for survivability.
Here you can see the modern safety helmets OSHA is recommending. They're rapidly becoming the new industry benchmark. And let's tie this right back to what we learned just a few minutes ago in the last module. When you're choosing these helmets, remember those hazard-specific electrical ratings. A Class E safety helmet will give you up to 20,000 volts of electrical protection, while a Class G gives you up to 2,000 volts. So by wearing the right helmet and buckling that chin strap, you're defending against a dropped wrench and a live overhead wire at the exact same time. Now that is smart, proactive safety.
Section 4. Pro tips and exam prep. These are the crucial daily habits that save lives. Number 1, attach tool lanyards. If you're working at heights, tie your tools off. A falling tape measure from 4 stories up can fracture a skull. I have seen it happen. Number 2, maintain high visibility clothing anytime you're near vehicles or heavy equipment. Be seen to be safe. If your vest is covered in dirt and grease and doesn't reflect light anymore, toss it and get a new one. Number 3, obey drop zones and swing radius barricades. If there's red tape around a crane's swing radius, you treat it like a solid brick wall. You just do not cross it.
And number 4, always secure and evenly lift your loads. Prevent the slip before it ever happens. Look, these aren't just exam answers, these are the habits of a true construction professional.
I want to leave you with this absolutely crucial distinction for your exam. Struck-by hazards can sometimes look a whole lot like caught-in hazards out in the field. So how do you tell the difference when you're taking the test? Well, here's the golden rule. If the impact alone is what hurts you, it is a struck-by hazard. But ask yourself, what happens if that heavy machine doesn't just hit you, but pins you against a concrete wall? If the object traps you or crushes you between two pieces of equipment, well, that's a caught-in hazard. Which brings us exactly to the terrifying reality of trenches, gears, and barricades as we dive straight into Module 7.
All right, let's keep the momentum going. We just wrapped up struck-by hazards, where the danger is something flying or falling and literally making forceful contact with you. Now we're shifting gears right into the next critical part of OSHA's Focus 4. We are diving deep into caught-in and caught-between hazards. These are those terrifying incidents where things get pinned, crushed, or pulled in. And let me tell you, avoiding these requires a completely different level of situational awareness on the job site. I know these two can sometimes get a little blurry out in the field, so let's clear it up. Over on the left, a struck-by hazard means the object is moving and hits you. Think of, say, a brick falling off a scaffold and clocking your hard hat. But over on the right, a caught-between hazard, that means you are being crushed, pinned, or squeezed. Usually, this happens between a moving object and a stationary object, or maybe between two moving objects. It's basically the difference between getting bumped by a backing dump truck and being totally crushed between that backing dump truck and a solid brick wall. Out on the site, recognizing that subtle difference is going to dictate exactly how you protect yourself. And honestly, nowhere is that crushing danger more real than right here in the dirt. Look at this worker entering a trench. A lot of folks look at a trench and just see a hole in the ground. Well, I've been on job sites for over 15 years, and I need you to change how you view soil right now. Soil is dead weight. Just 1 cubic yard of dirt can weigh as much as a small car. We're talking around 3,000 pounds. If a trench wall collapses, it doesn't just fall on you. It actually acts like a liquid. It flows in, fills every single gap, and packs solidly around your body. You don't get pushed out of the way. You get pinned. That is a textbook caught-in hazard, and it's exactly why excavation work is so strictly regulated.
So the absolutely crucial point here is this number, 5. Go ahead and consider this a massive exam tip. According to OSHA's excavation standards, specifically Subpart P, if you are stepping into a trench that is 5 feet deep or more, protective systems are absolutely, unequivocally mandatory. No exceptions. You do not get to say, hey, I'll just be down there for 2 seconds to grab a pipe. 5 feet is roughly up to the chin for most of us. If that collapses, your chest is instantly compressed by thousands of pounds. You literally cannot expand your lungs to take a breath. It's game over.
Now, how do we actually engineer safety into the earth itself? OSHA gives us 4 main methods. First is sloping, where we literally angle the trench wall away from the excavation. Second is benching, which forms a series of wide stair-like steps to safely reduce the wall height. Third is shoring. This is where we use aluminum hydraulic systems to physically brace the walls apart so they just can't move. And finally, shielding. This involves dropping in a heavy trench box. Shielding doesn't prevent the cave-in, but it acts like a heavy steel fortress around you if the walls do decide to let go. Before your boots ever touch the dirt, one of these life-saving protocols has to be completely in place.
But hey, you can't just drop a trench box in the mud and call it a day, right? Trench inspections are a daily requirement. Step 1, the excavation has got to be inspected by a competent person. In OSHA terminology, that's a very specific designation for someone who can spot existing and predictable hazards, and most importantly, has the explicit authority to stop work immediately. They're out there looking for soil fissures, water buildup, or even vibration from nearby traffic. And look closely at Step 3. I cannot stress this enough. If the absolute worst happens and a trench collapses, untrained workers must never, ever attempt a rescue. It's human nature to want to grab a shovel and dig out your buddy. I get it, but in almost every recorded case, that just causes a secondary collapse, turning one tragic fatality into 2. Only highly trained, specially equipped personnel perform trench rescues, period.
Now, let's think about the heavy iron that usually digs those trenches. Take an excavator operating right on the edge of an excavation. This brings us to another massive caught-between hazard. You've got crews working down in the dirt, and you've got thousands of pounds of steel swinging right above and beside them. The level of situational awareness you need around excavators, loaders, and cranes is just immense.
We're up against some serious hazards with this equipment. Notice the big warning symbol over the swing radius of that excavator. The heavy counterweight on the back of that machine swings out incredibly wide, and the operator often has massive blind spots directly behind them. If you're standing between that swinging counterweight and a fixed object, like a jersey barrier or a building wall, you will be crushed. On the right, look at this worker under the raised bed of the dump truck. That is a lethal pinch point. If the hydraulics fail, or if a coworker accidentally bumps the controls in the cab, that bed comes crashing down. You absolutely have to maintain eye contact with equipment operators at all times and stay completely clear of these pinch points and equipment swing areas. And if you are the one sitting in the cab operating the heavy iron, I want you to burn this quote right into your memory. Consider this a major exam tip, but far more importantly, a life-saving tip. Use heavy equipment that has a ROPS and fasten the seatbelt. ROPS stands for Rollover Protective Structure. It's that reinforced metal cage or roll bar built around the cab. But here's the critical part that folks always seem to forget. That ROPS does absolutely nothing for you if you get thrown out of the seat during a rollover and get crushed by your own machine. The seatbelt is the only thing that keeps you inside that protective cage, so you fasten it every single time you turn the key. Okay, let's step away from the heavy earth movers for a second and zoom in on the smaller, localized hazards. We're talking about machinery hazards, unguarded gears, belts, pulleys, and even your handheld power tools. These are your classic, everyday, caught-in hazards. A really common mistake I see out there is guys walking around with unzipped high-vis vests or dangling safety lanyards. It is incredibly easy for one of those, or a loose shirt sleeve, a baggy glove, or even long hair, to get grabbed by a spinning gear or a moving belt. And listen, once a machine grabs a piece of you, it does not have the brain power to stop. It's just going to keep turning and pull your body parts directly into the mechanism.
So, how do we safely service, repair, or unjam these machines? Enter lockout/tagout, widely known on the site as LOTO. This falls right under OSHA standard 1910-147. This is the mandatory procedure used to ensure equipment is fully shut off, physically isolated from its energy source, and rendered completely inoperable before you even think about putting your hands near the danger zone. From my years on the tools, I can promise you that bypassing LOTO to just quickly fix a jam or make a 5-second adjustment is one of the most common and, frankly, most fatal mistakes a worker can make. You lock it out, you tag it out, you hold the key.
Now, when the machine is actively running and doing its job, we rely on machine guarding. The rule here is super simple. Guards stay on. You never remove or creatively bypass them just to speed up a cut. These guards are specifically engineered to ensure your fingers and hands literally cannot reach the point of operation. And they actually serve a second purpose that folks often forget about. They prevent tools or loose objects from falling into the moving parts and becoming dangerous high-speed projectiles. So if a guard is missing, if it's broken, or if it's easily removable, you do not run that machine. Just tag it out and get it fixed. All right, we've covered a lot of ground here, from the terrifying weight of a collapsing trench down to the high-speed gears of a table saw. Let's shift gears right into our actionable prevention strategies. Let's do a rapid-fire rundown of these daily safe behaviors. Now, they might seem like common sense, but believe me, they are your absolute best defense. Maintain direct eye contact with heavy equipment operators. The rule of thumb is simple. If you cannot see their eyes in the mirror, they definitely cannot see you. If things get tight, use a dedicated spotter to guide the iron safely. When staging materials, stack them securely so they don't unexpectedly slide, fall, or collapse and pin somebody against a wall. Always tuck in loose clothing or dangling jewelry that can get snagged on passing equipment. And never, ever stand under suspended loads. These aren't just suggestions for the new guys. These are the daily, non-negotiable disciplines of a professional construction worker. Now, if you're walking the site and you do spot a hazard, let's say you see an unguarded drive belt, or maybe a trench wall that looks a little unstable, here is your critical rule of 3 protocol. Step 1, stop work immediately in that specific area. Step 2, warn others around you so nobody accidentally walks right into the trap while you're dealing with it. Step 3, notify your supervisor so the hazard can be permanently and properly corrected. Safety is not just the safety manager's job, it is everyone's responsibility. You are the eyes and ears out there. We put all these fantastic protocols in place, right? The heavy trench boxes, the steel machine guards, the strict lockout procedures, all of it is designed to keep the hazards as far away from your physical body as possible. But construction is a dynamic beast. What happens if the hazard still reaches you? What if an object slips, a swing radius is breached, or a piece of material kicks back despite our absolute best efforts? That brings us to our final, most intimate layer of defense. Let's keep moving forward and look at exactly how we armor ourselves for the unpredictable.
All right, so we just wrapped up all those nasty crushing and pinching hazards in Module 7, right? Figuring out how to stay clear of moving equipment and shifting trenches. But look, even with the absolute best situational awareness in the world, things happen on a construction site. And that is exactly where this masterclass explainer comes into play. Module 8 is all about personal protective equipment, or PPE. Think of this as your final layer of personal armor on the job site. Let's get right into it.
Here's our hit list for this explainer, just so you know exactly what we're going to cover to keep you safe and, to make sure you pass that OSHA 30 exam. 1. The last line of defense. 2. Responsibilities and payment. 3. A head-to-toe gear guide. 4. Proper fit and maintenance. And finally, 5. Going home safe.
Starting off with Section 1, the last line of defense.
So, the hierarchy of controls is a massive, absolutely crucial concept in OSHA safety. I mean, you've got to remember this. Our first choice is always engineering controls. Basically, can we physically change the work environment to eliminate the hazard entirely? Like maybe adding ventilation to clear out fumes or slapping a physical guard on a saw. Now, if we can't do that, we move to administrative controls, changing how or when we work. Think of rotating workers out of high noise areas just to limit their exposure. But if those first two fail, or they just aren't physically feasible, what's left? Well, PPE. PPE is the final barrier. It sits at the absolute bottom of that hierarchy. It is literally your very last line of defense. Meaning, if your PPE fails, you are taking the hit. And that is exactly why we take it so seriously. All right, moving to Section 2, responsibilities and payment. Under OSHA Standard 1910-132, the employer has an absolute, non-negotiable duty to perform a hazard assessment before anyone even steps foot on the job site. The boss has got to walk the site, assess the workplace for physical and health hazards, actually select the specific PPE that'll protect against those hazards, ensure it actually fits the affected employees, and here is the kicker. They must certify it in writing. It's a living document. Real job site scenario here. You absolutely cannot just buy a bulk box of cheap safety glasses, dump them in the job trailer, and call it a day. Doesn't work like that. Now, I'm going to give you a massive construction orange exam tip right here, so pay attention. OSHA issued a rule that makes it very, very clear who pays for what. The employer pays for the specialized protective gear used to comply with OSHA standards. We're talking things like your hard hats, non-prescription safety glasses, fall protection harnesses, and those specialized chemical-resistant gloves. But what does the worker pay for? Well, you buy your everyday items, your normal work boots that don't have special requirements, your standard cold weather gear, and your normal daily clothing. You definitely want to keep that distinction crystal clear for the test. Moving right along to Section 3, head-to-toe gear guide. So here is your standard construction job site PPE loadout, pulled right out of OSHA 1926.95. You've got your hard hat, safety glasses, high-vis gear, proper gloves, and safety toe boots. Look, this is the everyday armor for American construction workers. If you're walking onto an active site, anywhere, this is your minimum baseline, no exceptions. Let's start right at the top with head protection. Hard hats have to meet the ANSI Z89.1 standard. They are specifically designed to resist penetration from drop tools and, actually absorb the shock of a heavy blow. But you really need to know the specific classes here. Class G is for general use, giving you limited voltage protection up to 2200 volts. Class E is for electrical work, and those are proof tested all the way up to 20,000 volts. And Class C, well, that stands for conductive. Remember this, it offers zero electrical protection. None. It's usually made of aluminum or has these big cooling vents, so you never ever want to wear a Class C hat anywhere near live electrical hazards. Which actually brings us to a strong red common mistake I see out on job sites literally all the time. The right way to treat your hard hat is to constantly inspect the shell for chalking, cracks, or dents. The absolute wrong way? Slapping a bunch of unauthorized stickers or spray paint all over the thing. Look, paint chemicals actually weaken the plastic, and man, I've seen guys try to hide massive, deadly cracks under a cool union sticker. If a Henley wrench drops on your head from 3 stories up, you really do not want a compromised shell failing on you. All right, moving down to the eyes and face. Eye protection has got to comply with ANSI Z87.1. Safety glasses are your standard everyday barrier for flying particles and impact hazards. Now, if you're dealing with chemical splashes, you need indirect vented goggles that actually seal tight to your face. And here is a pro tip regarding face shields. A face shield alone will absolutely not stop a high-speed impact from a grinder or a saw. A face shield must always be worn over your Z87.1 safety glasses or goggles. The glasses stop the impact, the shield stops the spray. Make sense? All right, dropping another construction orange exam tip right here, this time for hearing protection. The magic number you need to literally burn into your memory is 85 decibels. If you're exposed to an 8-hour time-weighted average of 85 dBA, that is the exact trigger for an employer's mandatory hearing conservation program. That means noise monitoring, audiometric testing, and making properly fitted earplugs or earmuffs available. Guys, don't lose your hearing over a loud compressor. It's just not worth it.
Now, for our lungs, we've got respiratory protection. And look, respirators are no joke. You can't just hand a guy a paper mask and tell him to get to work in some dusty, enclosed room. OSHA requires a strict written respiratory protection program. That means you need a medical evaluation first, just to make sure your heart and lungs can actually handle the physical strain of breathing through that filter, followed by a proper fit test to ensure the seal is completely airtight against dusts and toxic fumes.
Okay, let's talk about the extremities, your hands and feet. You have absolutely got to match the glove material to the hazard. Nitrile is for chemicals, heavy leather is for welding or handling rough steel, and Kevlar or steel mesh is for severe cut hazards. And for your feet, you need safety toe footwear meeting the ANSI Z41 or ASTM F2413 standards. Trust me on this one, a dropped piece of heavy rebar or a rolling pipe will completely shatter your toes if you're not wearing them.
Finally, on our gear tour, we have personal fall arrest systems. When you are working at heights, your full body harness, lanyard, and anchor point act as a super critical part of your PPE armor. If you slip, it is literally the only thing keeping you from hitting the ground.
All right, Section 4, proper fit and maintenance.
Look, before you are ever allowed to use a piece of PPE on the site, OSHA requires you to be trained on these exact 5 things. 1. When is the PPE necessary? 2. What specific kind of PPE is needed for the task? 3. How do you properly put it on, adjust it for a snug fit, and take it off? 4. What are the actual limitations of the gear? And 5. How do you care for it, maintain it, and eventually dispose of it? You've got to demonstrate you understand these 5 points before you even think about starting work.
And I really need to hammer home this strict OSHA rule from 1910.132. Defective or damaged personal protective equipment shall not be used. Period. End of story. If your safety glasses are so scratched up that everything looks foggy, if your hard hat shell has a deep gouge, or if your fall harness has a frayed strap, you remove it from service immediately. Cut the strap, throw it in the trash, and go get a reliable replacement from your supervisor.
Which brings us to Section 5, going home safe. We aren't wearing safety glasses for compliance. We're wearing them so we can see our kids play baseball. Look, this is what it's all about. I've been an outreach trainer and working in construction safety for over 15 years, and I can tell you straight up, the citations and the fines, they don't matter nearly as much as your life does. That hard hat, those boots, those safety glasses, they are fundamentally about protecting your family's future. They ensure you walk off that site the exact same way you walked on and get home to your people every single night. So ask yourself this. Now that your harness fits right, your boots are laced up, and your gear is fully inspected, where exactly will you be tying off when the ground disappears beneath you? We're taking all that PPE knowledge and applying it right now, because up next is Module 9, Scaffolds. Let's jump right in. All right, so you've got your harness fitted perfectly. Your personal fall arrest system is completely dialed in from our last discussion, and you are good to go. But where exactly are you tying off? Well, you're going to be tying off on the very thing we're diving into right now, scaffolds. You see them on almost every single job site, and they are one of the most heavily regulated pieces of equipment in construction, for very good reason. Listen, you're going to spend a huge chunk of your construction career up on scaffolds, and it's serious business, clipping your lanyard in, managing your tools, and transitioning safely onto the deck. Because while these structures might look like giant adult-sized erector sets, a single missing pin, a loose plank, or a slightly bent cross brace, that can turn a great shift into an absolute disaster in the blink of an eye. I want you to burn this number into your memory, 4,500. Every single year, there are roughly 4,500 injuries related to scaffolding right here in the US. That is thousands of our brothers and sisters taking a spill, getting struck by falling materials, or worse, riding a collapsing deck right down into the mud. It's a staggering number for something we literally use every single day. And here is the really tough part. Those accidents lead to over 50 fatalities annually. That's 50 workers who punch in for their shift, but do not go home to their families. So when we talk about OSHA's Subpart L rules for scaffolds, we aren't talking about bureaucratic red tape. Those rules are literally written in blood. They exist because we've had to learn the hard way exactly what happens when we skip an inspection or take a shortcut.
So before a single piece of tubular steel even goes up on site, or a plank gets laid down, we have to establish exactly who is in charge of this structure. Notice the specific language OSHA uses here. A competent person is someone capable of identifying existing and predictable hazards and, here is the absolute kicker, has the authorization to take prompt corrective measures. On your job site, competent person isn't just a fancy title you give to the guy who's been around the longest. It is a specific individual with the training, the deep knowledge, and the absolute authority to stop work and fix a hazard immediately. If they see a bent frame, they stop the job. Period. No questions asked.
And this competent person has a massive responsibility. They have to thoroughly inspect that scaffold before every single shift. Every morning before you even think about setting a boot on that ladder. But it's not just a morning routine. They also have to re-inspect it after any crazy weather event like high winds or heavy rain, or if, say, a forklift accidentally bumps the frame. They are out there checking the foundation, the frame, the bracing, and the planks to make sure the structural integrity is 100% solid.
All right, let's walk through building one of these things the right way, starting exactly where it matters most, the foundation. Because if your foundation is garbage, the rest of the structure is a death trap.
Gravity always wins, folks. You can't build a scaffold on soft dirt, and you sure as heck can't stack it on cinder blocks or scrap lumber. I've been doing this for over 15 years, and I still catch guys trying to level a scaffold leg with a loose brick. You need proper mud sills and base plates on every single leg to distribute that load evenly into firm ground. Those screw jacks? They must be used correctly to keep everything dead level, but never, ever overextended past their limits. And your uprights have to be perfectly plumb and tightly braced.
Moving up to the working deck, you can't just grab any random piece of plywood or a 2x10 from the scrap pile and throw it up there. You need proper scaffold-grade planks. You want to look for that OSHA stamp right on the wood. These boards are straight-grained, they're free of major splits or rot, and they are specifically graded to handle the dynamic, heavy loads of construction work. Once you've got the right materials, every single platform on all working levels has to be fully planked or decked between the front uprights and the guardrail supports. We are talking gaps no wider than 1 inch. You do not want a framing hammer slipping through a gap and braining the guy working below you. And generally speaking, these platforms need to be at least 18 inches wide, so you actually have the room to stand, turn, and work safely without performing some kind of high-wire balancing act. Now, once that platform is built, you absolutely have to respect the load limits. It is so incredibly easy to accidentally overload a bay, especially when you start hoisting up heavy materials like pallets of brick or cinder block right next to your masonry crew. Exam tip right here, guys, so lock this in. A scaffold and its components must be able to support its own weight plus at least 4 times the maximum intended load. 4 times. There are 0 exceptions to this rule. And if you're working on a suspension scaffold, like those swing stages you see hanging off high-rises, the rigging must support 6 times the intended load. Never, ever overload your platforms. You need to know your duty ratings before you start stacking. Okay, so we've got a solid foundation and a really strong deck, but we still need to make sure you don't accidentally step backward off the edge. Take a mental snapshot of these numbers right now, because they are critical. If your scaffold was built after the year 2000, your top rail must be between 38 and 45 inches high, and it has to be able to withstand 200 pounds of downward or outward force. Your mid-rail goes exactly halfway between the top rail and the deck, and that has to take 150 pounds of force. And you absolutely must have toe boards installed. They need to be a minimum of 3.5 inches high. A wrench falling from 40 feet is a lethal weapon. Those toe boards are there to stop your tools from kicking off the edge. And remember this golden rule. The standard fall protection trigger height in construction is 6 feet, right? But on scaffolds, it's 10 feet. The very moment you are working on a scaffold 10 feet or more above a lower level, OSHA mandates that you are protected from falls. You achieve this either by having that fully compliant guardrail system we just talked about in place, or by properly tying off with your personal fall arrest system. All right, so we've built a bulletproof platform with solid guardrails. But honestly, none of that matters if you break your neck just trying to climb up to it. Listen to me on this one, because I see this violation on almost every job site I visit. Do not be the guy climbing the diagonal cross braces like it's a playground jungle gym. It is incredibly dangerous and it is flat out illegal. The right way, you use a proper attachable ladder that extends at least 3 feet above the platform, or you use a designated stair tower or an integral frame access that's specifically designed for climbing.
Here are the hard rules for access. Anytime your platform is more than 2 feet above or below your access point, you must have a safe way up. You can't just vault onto it like an acrobat. The bottom step of your ladder or stair tower cannot be more than 24 inches off the ground or supporting level. Make sure all your treads are slip resistant, and I'm gonna say it one more time, never climb those cross braces.
Before we wrap up our talk on scaffolds, let's look at the everyday shortcuts that end up getting guys severely hurt and companies slapped with massive OSHA fines.
The biggest mistakes out there? Taking a guardrail down just to load some material and leaving it off just for an hour. Or riding a mobile scaffold while someone pushes you across the floor. We call that scaffold surfing, and it is a huge no-no. Another fatal mistake is setting up way too close to energized power lines. You must maintain at least 10 feet of clearance from live power lines. No exceptions.
Always take a second to look at your hardware. Verify that all your locking mechanisms, your pins, your J-locks, your U-locks, are fully engaged. Make sure your deck hooks are seated completely flush before you put your body weight on that plank. A scaffold can look totally solid from the ground, but if those pins aren't locked, the whole thing can fold up like a cheap suit.
And here's a pro tip right from the field. Weather and heavy machinery move things. If it rained hard overnight and softened the mud under your sills, or if an excavator swung around and just bumped the frame, the structural integrity might be totally gone. Always get your competent person to re-inspect the setup if the environment changes before you climb back up there. Respect the structure, guys, because when a scaffold is built right, the work moves with a safe and steady rhythm. It makes the job easier, it makes the work go faster, and most importantly, it ensures everybody punches out and goes home to their families. That is exactly why we do this. Now, scaffolding is absolutely fantastic for a fixed position. But what if the job requires you to move quickly between different levels? Or you're working in a really tight stairwell where a scaffold frame just won't fit? When you need to be highly mobile, you're going to have to reach for something else. So let's shift gears seamlessly right here, step off the deck, and look at exactly how to set up your ladders and stairways without taking a spill.
So, we've got your scaffold systems properly erected, fully planked, and locked down tight. Good. But now, we need to immediately look at the equipment you use to actually get up there. Ladders and stairways. As your instructor for this OSHA explainer, my absolute main goal is to keep you alive and, yeah, keep your site fine-free. You can build the most perfect OSHA-compliant scaffold in the world, but man, if your access point is a disaster, you've just built a trap. So let's dive straight into the everyday tools we all use and honestly take for granted way too often.
1,069. Just let that number sink in for a second. Last year alone, falls from elevation claimed the lives of 1,069 construction workers. That's over a third of all construction deaths. And here's a real job site scenario for you. A massive percentage of those fatalities, they didn't start with some dramatic movie-style collapse of a skyscraper. No, they started from a simple, rushed mistake on a ladder. A bad setup, a skipped inspection, leaning out just a little too far. We're going to fix that right now.
Okay, before you even place a boot on a rung, we got to talk about inspections. Here's a huge exam tip. Under OSHA Standard 1926.1053, a designated competent person absolutely must inspect that ladder for visible defects, oil, grease, and structural damage right at the start of your shift. And frankly, after any occurrence that could affect its safe use. I'm talking about checking for cracked side rails, missing cleats, loose hinges, the whole shebang. You don't just yank a ladder off the truck and go. You've got to inspect it.
Now, if you're doing that inspection and you spot cracked rails, missing rungs, or heavy corrosion, you have to immediately remove that ladder from service. Remember this, you do not just lean it against the chain link fence where the next crew might grab it. No way. You must physically tag it dangerous, do not use, or something very similar, and get it completely out of the active work area until it's repaired or tossed. You are actively protecting the guy coming up behind you so he doesn't make a fatal mistake.
Which brings me to a massive common mistake I see regarding ladder repairs. In my 15 years walking job sites, the absolute wildest things I see are guys trying to tape, wire, or splice broken wooden job-made ladders. Listen to me on this. OSHA requires that any ladder repair must restore it to its exact original design criteria. If you've got a compromised fiberglass side rail or a bent aluminum step, you aren't fixing that with duct tape, buddy. If it cannot be perfectly restored to the manufacturer's spec, cut it up and throw it in the dumpster.
All right, let's move to the actual setup. When you're positioning a non-self-supporting ladder, like an extension ladder or a straight ladder, there is a strict formula you have to follow. We call it the 4-to-1 rule. Now, This isn't just a friendly suggestion from the safety guy. This rule is literally the absolute geometry of safety. It's what keeps the bottom from sliding out and the top from tipping backward.
Here's exactly how it works, and jot this down because it's a huge exam tip. For every 4 feet of vertical climb height to your top support point, you must pull the base of the ladder exactly 1 foot away from the wall. This creates roughly a 75.5-degree angle. It's a brilliant mathematical ratio because it maximizes the downward force locking the ladder's feet to the dirt while minimizing the outward sliding force at the top. So say your landing is 20 feet up. The base of your ladder needs to be exactly 5 feet out from the wall.
And speaking of that landing surface, here's another critical number for you. When you're using that extension ladder to access an upper landing or roof, the side rails must extend at least 3 feet above that landing surface. Why? Because the moment you transition from the ladder to the roof is easily the most vulnerable point of the entire climb. That 3-foot extension gives you a continuous, solid handhold to grip while you shift your center of gravity over. If you just can't get 3 feet of extension due to the ladder's length, you have to rigidly secure the ladder at the top and install a grab rail. But hey, all that beautiful geometry means absolutely nothing if your base is garbage. You must secure your ladder on a stable, level surface. Those slip-resistant feet are completely useless if you sink into a mud puddle or hit a patch of black ice. And never, ever place a ladder on boxes, barrels, or pallets to cheat a few extra feet of height. Here's a pro tip. If you're setting up in a high-traffic area, a driveway, or in front of a door that opens toward you, secure the ladder and throw up a barricade. Do not let a swinging door be the reason you take a 15-foot ride to the concrete.
Okay, so the ladder is set perfectly. Now you've got to climb it. The absolute biggest red tag offense I see on sites is a guy carrying a heavy drill, a bucket of mud, or framing lumber up a ladder. Doing this completely destroys your 3-point contact, meaning 2 hands and 1 foot, or 2 feet and 1 hand securely on the ladder at all times. Look, unless you've got a prehensile tail, you cannot maintain 3 points of contact with a circular saw in your hand. Climb the ladder empty-handed and use a hand line or a material hoist to pull your gear up once you are safely tied off.
Once you're actually climbing, I want you to remember the belt buckle rule. Always face the ladder. Keep your center of gravity, literally your belt buckle, strictly between the side rails at all times. If you lean way out to reach that far bolt or paint that corner, you are going to shift the weight right off the feet and kick the base out from under you. Listen to me on this. If you can't reach it comfortably with your buckle between the rails, climb down and reposition the ladder. It takes 2 extra minutes and it might literally save your career. Let's talk specifically about A-frame stepladders and some really common mistakes I see. First, do not ever use the top step or the top cap as a step. I mean, it clearly says so right on the ladder. Second, never use a folded stepladder horizontally like it's a platform or a scaffold plank. They are engineered to support vertical weight only, and I promise you they will snap if you load them sideways. Finally, never climb the cross bracing on the rear section unless the ladder is specifically designed with dual-sided steps. And please, never try to walk or hop the ladder while you're standing on it. Now, what about fixed ladders? You know, the ones permanently attached to buildings or tanks. Here's an exam tip. If you're climbing a fixed ladder and the total length of the climb equals or exceeds 24 feet, OSHA regulations require modern fall protection. We're talking about ladder safety devices like a cable system with a body harness or self-retracting lifelines. We've learned the hard way over the years that traditional cages alone do not actually stop a fall. They basically just bounce you around on the way down. So 24 feet is your magic trigger for active fall protection.
Pivoting over to stairways on the job site. This is an area guys treat as an afterthought all the time, but OSHA is incredibly strict here. At any point of access where there's an elevation break of 19 inches or more, and no ramp, runway, or sloped embankment is provided, you must provide a stairway or a ladder. Think about this real job site scenario. You just can't expect your crew to vault up a 2-foot retaining wall 50 times a day, carrying heavy materials. Honestly, that is just a blown knee waiting to happen.
And whether you're using a temporary wooden job-built stairwell or a permanent metal installation, the rules apply. You must have handrails installed the second you hit 4 risers, or 30 inches of vertical height. Riser height and tread depth absolutely have to be uniform. Why? So workers don't trip from muscle memory expecting a different step height. Pan stairs must be filled to the top edge before foot traffic is allowed, and all platforms and landings must be kept totally clear of debris.
And this brings up a quote that brilliantly illustrates the core philosophy we operate under. OSHA states clearly that injuries caused by improper ladder use are 100% avoidable. Every single fall scenario we just talked about, it's a result of a rush setup, a skipped daily inspection, carrying tools by hand, or leaning out too far.
That means every single incident is completely within your power to prevent. It is all about the choices you make before you even put your foot on that bottom rung. To make this your everyday routine, keep the climb method in your head. C. Choose the right equipment, meaning the right height and duty rating for your weight plus your tools. L. Look for damage before every single shift. I. Implement safe setup, using that 4-to-1 angle and a solid base. M. Move safely by keeping 3 points of contact and facing the ladder. And B. Be an expert. Know the standards we've covered in this explainer and have the courage to correct anyone you see doing it wrong on your site.
So, the absolutely crucial point is this. The clear, secure stairways and ladders we just inspected and built to get you safely up to your workspace, well, those are the exact same lifelines you'll need to rely on to escape if things go horribly wrong. Access and egress are literally two sides of the exact same coin.
Just think about it for a second. If a massive fire broke out on your level right this very second, is your stairway completely clear, or did somebody just leave a stack of drywall, an extension cord, and a lunch cooler sitting right on the landing? Let's keep moving and look closely at how we secure those escape routes and protect the site, because it's time to tackle our next critical topic, fire protection and prevention.
You just spent a good chunk of time mastering the safe use of ladders and stairways, and I guarantee you're going to view those access points a whole lot differently on the job site now. But let's raise the stakes for a second. Imagine you're on the 4th floor of a new build, someone yells fire, and that stairway you just inspected is suddenly your only way out. When things go sideways, those exit routes literally become your lifeline. Over my 15 years as a safety instructor, I've seen firsthand how fast a tiny, innocent-looking spark can turn into a total catastrophe. So grab your notebooks, get focused, and let's dive right into how we keep our sites from going up in smoke.
Building directly on what we just covered, there is a hard and fast rule you've got to follow. Keep your ladders and stairways 100% clear of flammable storage. I literally cannot tell you how many times I've walked onto a site and found crews stashing paint thinner, solvents, or oily rags right under a stairwall. Usually, they just want to keep the stuff out of the rain or out of the main walkway. I get it. But here's the job site reality. Storing flammables near or under stairways, near elevators, or in exit routes could completely cut off your crew's ability to safely evacuate if those liquids catch fire. Local building codes and very strict OSHA regulations prohibit this for a reason. If a fire breaks out, those clear exit routes are it. They are your only lifeline, period.
Now, to prevent fires, you first have to understand exactly how they start. We all know the basic fire triangle, right? Oxygen, fuel, and heat. But let's demystify the science here a bit, because understanding a liquid's flash point is absolutely critical. Listen closely. It's actually not the liquid itself that burns, but the vapor the liquid gives off. The flash point is the absolute minimum temperature at which a liquid gives off enough vapor to form an ignitable mixture in the air around it. So if you have an ignition source nearby, those invisible vapors are what actually catch fire or explode. If you only take away one piece of science from this whole explainer, make it this: respect the invisible vapors. So how exactly does OSHA define a flammable liquid? It is any liquid having a flash point at or below 199.4 degrees Fahrenheit. Now, why does that specific number matter to you? Because it highlights just how easily these chemicals can turn into highly dangerous vapors at completely normal ambient temperatures. Let me give you a real job site scenario. Say you're using a solvent with a flash point of 65 degrees Fahrenheit. You accidentally spill a bit indoors and the room temperature is, say, 70 degrees. That liquid is immediately generating a massive amount of vapor. If enough of that vapor mixes with the air in that 70-degree room, any nearby spark could ignite it instantly. There's no warning.
Because not all liquids behave the exact same way. The Globally Harmonized System, or GHS, breaks flammable liquids down into 4 categories. Category 1 is the most volatile and dangerous. These are liquids with flash points below 73.4 degrees Fahrenheit and boiling points at or below 95 degrees. They evaporate incredibly fast and ignite at very low temperatures. Now, Category 4 liquids are the least volatile on this scale, but remember this: if you heat a Category 4 liquid up for a specific job, it starts acting just like the more dangerous categories. As a supervisor or a worker, knowing exactly which category you are handling dictates the strictness of the job site handling and storage rules you've got to follow.
All right, let's think back to our fire triangle. We've got the fuel, and, well, oxygen is everywhere. All a fire needs now is heat, an ignition source. And let's be honest with ourselves. A construction site is basically a giant factory for heat and sparks. Common sources of ignition include open flames, lightning, smoking, hot surfaces, frictional heat, and, of course, cutting and welding operations. We see these every day. But some ignition sources are completely invisible.
and they catch even veteran workers off guard all the time. And that perfectly sets up our next major, often invisible hazard: static electricity. Just the physical act of pouring a flammable liquid from one metal drum into a plastic or metal container creates friction. That friction builds up a static electrical charge. If a spark jumps from the liquid to the funnel, boom! Those invisible vapors we talked about earlier ignite in a flash. To prevent this, OSHA requires you to use bonding and grounding. Bonding simply means physically connecting the two containers with a highly conductive wire to equalize the charge between them. Grounding connects the container directly to the earth with a ground wire. It is such a simple step, guys, but skipping it is a deadly and unfortunately common mistake.
Let's talk about the most obvious ignition source out there: hot work. Welding, cutting, and heating. The rules here are strict and non-negotiable. Step 1. If practical, move the object you are welding to a designated safe location. If you can't move it, you must move all movable fire hazards out of the vicinity. Just get them out of there. Step 2. If hazards absolutely can't be removed, you've got to use fire-resistant shields to confine the heat, sparks, and slag. And Step 3, this is a big one, assign a dedicated fire watch. Pro tip here: a fire watch isn't just someone standing around leaning on a broom while the welding happens. They must be equipped with a fire extinguisher, specifically trained on the anticipated hazards, and they must remain on guard for a sufficient period of time after the work is totally completed. You have to make sure no smoldering embers burst into flames when everyone goes on lunch break.
Okay, grab your pens because I'm about to drop a high-value OSHA exam tip. We are moving into portable firefighting equipment. I want you to keep the number 3000 in your head. OSHA requires that you provide one 2A-rated fire extinguisher for every 3,000 square feet of protected building area. That means if you have a 6,000 square foot floor, you need at least two. If it's a multi-story building, you need at least one on every single floor, and it must be located right next to the stairways. Let's move to the next strict OSHA requirement, which is the number 100. It is not enough to just have the extinguishers somewhere in the building. They actually have to be accessible. The travel distance for any worker to reach the nearest 2A-rated fire extinguisher must never exceed 100 feet. Think about it. If a worker has to sprint 200 feet across a massive warehouse just to find an extinguisher, the incipient fire, that's the small, early-stage fire, will have already grown completely out of control by the time they get back. 100 feet maximum travel distance. Lock that into your memory. And the rules get even tighter when we bring flammable liquids into the mix. The number here is 50. If you are using more than 5 gallons of flammable or combustible liquids or 5 pounds of flammable gas on the job site, OSHA requires that a 10B rated extinguisher must be provided within 50 feet of that operation. You are dealing with a much faster, much hotter potential fire, so your allowable travel distance is immediately cut in half.
Now, what do those letters A and B actually mean? You can't just grab any red cylinder off the wall and start spraying. Using a water-based Class A extinguisher on an electrical fire, that could easily electrocute you. Using it on a grease fire will literally cause an explosion. Class A is for ordinary combustibles, your wood, paper, cloth. Class B is for flammable liquids, oils, and greases. Class C is for energized electrical equipment, Class D is for combustible metals like magnesium or titanium, and Class K is for commercial kitchen fats and oils. Supervisors, it's on you. You must ensure you have the correct class of extinguisher staged for the specific work happening in that zone.
If you are trained and authorized to use an extinguisher on an incipient stage fire, you must know the practical hands-on pass method. Listen, it's incredibly stressful when a fire breaks out and people tend to panic. The pass method gives you a crystal clear procedure. P. Pull the pin. A. Aim low, pointing the nozzle at the base of the fire, not up at the flames. S. Squeeze the lever smoothly. And S. Sweep side to side, covering the base of the fuel source until the fire is completely out. It is a super simple acronym, but under pressure, having that drilled into your head absolutely saves lives.
So you know how to use an extinguisher, but here is the most critical decision you will ever make as a worker. When do you fight and when do you run? The difference between incipient firefighting and evacuation is huge. Portable extinguishers are only designed for incipient fires, fires that are small, contained, and right in their beginning stages. If a fire is spreading quickly, if it's producing heavy smoke, or if your escape route is threatened in any way, do not play hero. The primary goal of any job site's emergency action plan is the immediate, safe, and orderly evacuation of all personnel. Remember, your life is worth way more than the building. We've covered the core of fire protection and exactly how an effective emergency action plan guides you to a safe exit. But let me leave you with a rather provocative scenario to chew on. Escaping a fire might save your life, sure. But what if your job site is an underground utility project and your only emergency exit route leads you directly into an unventilated tank, a deep trench, or a vault with bad air? You might escape the flames, only to find yourself walking into a completely different, totally invisible killer. How do we navigate, survive, and regulate those tight, dangerous environments? Keep that exact scenario right in the front of your head, because that is exactly where we're heading next as we dive into the hazards of confined spaces.
All right, we just wrapped up a pretty heavy discussion on fire and explosion hazards and exactly how to prevent those from ripping through a job site. But right now, I want you to take those exact same hazards and put them inside a box. Literally, because all those dangers we just talked about, they become exponentially deadlier when you are trapped inside a tank with them.
Ask yourself this. You know what makes a fire or a chemical leak 10 times worse? The terrifying reality out there on the dirt is that when things go sideways, being stuck in a tight hole turns a standard job site hazard into a fatal trap in a matter of seconds. I've been doing this for over 15 years, guys, and I can tell you right now, the dirt absolutely does not care how experienced you are. It doesn't care how many certifications you hold.
So what exactly are we talking about here? Let's break down the 3 strict OSHA criteria for a confined space. For a space to be officially confined, it has to hit all 3 of these bullets. First, it's large enough for you to physically enter and perform work. You can get your whole body in there. Second, it has limited or restricted means of entry or exit. That means you can't just walk out a standard door if things go bad. You might be climbing a ladder or squeezing through a hatch. And third, it is not designed for continuous human occupancy. It's a place you go to do a very specific job, not a place you're going to hang out and eat your lunch.
Now, you might be sitting there thinking, well, I don't work in chemical tanks or nuclear reactors, so I'm good. But listen to this list. Sewers, pits, crawl spaces, attics, boilers, tanks, silos, vaults. Does that sound familiar? You and your crew walk past these exact spaces constantly. They aren't rare. They are everywhere on a typical construction site, just waiting for someone to drop their guard.
Okay, let's dive into this next part, because this is where the rules fundamentally change. When does a regular tight spot escalate into a permit-required confined space, or a PRCS? Under OSHA 1926 Subpart A, it happens the moment that space contains, or even just has the potential to contain, a serious safety or health hazard. The absolute second that potential exists, strict protocols and a signed piece of paper, your entry permit, are completely non-negotiable before anyone breaks the plane of that opening. Here's a common mistake I see on job sites all the time. A crew assumes a space is perfectly safe just because it doesn't smell bad. Listen to me. Never trust your nose. You trust the permit and you trust the meter.
To really understand why we need those strict permits, we have to know exactly what's trying to hurt us. This brings us to the 4 deadly hazards: atmospheric, engulfment, configuration, and physical hazards.
Our first and honestly most common killers are atmospheric hazards. We are talking about the invisible killers. Things like hydrogen sulfide, which smells like rotten eggs and is incredibly common down in the sewers, or carbon monoxide. Let's look at a real job site scenario. Operating a propane-powered man lift inside a tank, or even just running an internal combustion generator near an open hatch. That can build up fatal levels of CO in minutes. Or maybe there's no gas at all, but it's an oxygen-deficient environment because something as simple as rust on damp steel actually sucked the oxygen right out of the air while the space was sealed up.
Now, grab your notebooks because here is a massive exam tip for you. Before you even think about entering that space, you have to test the air, and there is a strict, absolute order you must follow. Step 1. Test for oxygen. It must be between 19.5 and 23.5%. If your oxygen is too low, your other meters might not even give you an accurate reading. Step 2. Test for combustible gases. Step 3. Test for toxic gases and vapors. You do this in this exact sequence every single time before any part of your body breaks the plane of the opening.
Let's move on to the second deadly hazard: engulfment. If you are working in a grain silo, a sandhopper, or even a trench with loose soil, flowing solids act exactly like quicksand. The terrifying reality here is that it takes only 2 to 3 seconds to become completely helpless in flowing grain. Think about that. 2 seconds. You cannot fight your way out of it. The weight and pressure of that material on your chest will literally crush the breath right out of you.
Hazards 3 and 4 are configuration and physical hazards. Configuration means the actual physical shape of the space is a trap. Imagine inwardly converging walls or floors that slope down into a funnel-bottom bin where you can slide down, get wedged in, and asphyxiate. Physical hazards are all the things we face every day on the dirt, but amplified tenfold. Extreme heat or cold, exposed live wires, moving machinery like an auger that somebody forgot to lock out, or just simple slips, trips, and falls. Guys, if you break your leg walking across a normal floor, the ambulance comes to you. If you break your leg deep inside a 24-inch pipe, self-rescue is basically impossible.
So the absolutely crucial point here is preparation. Before anyone goes in, we have to isolate and control every single one of those hazards. We use tactics like line blanking. We physically lock out all moving parts. We set up forced air ventilation to keep the air cleaned. And we bleed or isolate pipes so that absolutely no unexpected hot steam, raw sewage, or toxic gas flows into the space while you are trapped inside it. Think of it this way. You cut off the beast's air supply and its food before you ever climb into its cage.
Now that the space is prepped and safe, let's talk about the crew. The entry team roles: entrant, attendant, and supervisor. A permit-required entry is never, ever a solo mission.
We start with the entry supervisor. This person is the boss of the whole, and I mean that. They don't just sign the paperwork and walk away to grab a coffee. The supervisor physically verifies that all atmospheric tests are done properly. The safety controls are locked in place. The rescue team is actually ready and on standby, and only then do they sign the permit. More importantly, they have the ultimate authority and the legal duty to cancel the entry and pull everyone out the second site conditions change.
Next up, we have the dynamic duo, the entrant and the attendant. The entrant is the worker actually down in the dirt doing the job. They wear the proper PPE, they communicate constantly with the outside, and if they suddenly feel dizzy or their personal air monitor goes off, they exit immediately, no questions asked. The attendant, on the other hand, stays strictly outside. Their sole job in life for the entire duration of that permit is to watch the entrant like a hawk. They manage the lifeline. They keep unauthorized folks away from the opening, and if things go wrong, they summon the rescue team. They do not check their cell phone. They do not turn around to go grab a wrench. They attend.
Which brings us to a remember this moment. This is the golden rule of confined spaces. Memorize this and take it to heart. The attendant never enters the space. I really don't care if your best friend is down there calling for help. The attendant stays outside, period. The only exception on this earth is if they are formally relieved by another qualified attendant and they themselves are fully equipped and specifically trained for an entry rescue.
Now, why am I being so hardcore about this rule? Because of one deeply chilling statistic: 60%. According to NIOSH, 60% of all confined space fatalities are would-be rescuers. Look, it's basic human nature. You see your buddy drop down there, you hold your breath, and you rush in to save them. But an invisible toxic atmosphere doesn't care how brave you are, man. It will drop you right next to them. That 60% represents real, hardworking people who died trying to be heroes without a plan. Don't become a statistic.
So how do we actually save a guy who goes down? We move to our emergency rescue procedures. You need to have a plan, not a panic. Just yelling for help or dialing 911 without a specific extraction plan is a guaranteed recipe for a tragedy. By the time the local fire department gets there and figures out what kind of hole you're even in, it's very often a recovery mission, not a rescue.
The absolute safest extraction method we have is what we call non-entry rescue. You use a tripod, a winch, and lifelines to gain a mechanical advantage right from the outside. If an entrant goes down, you just crank them straight up using the full body harness they are already wearing. It is quite literally the only way to perform a rescue without adding more bodies to the danger zone.
Now, if you are relying on an actual rescue team, whether that's an in-house crew you build or local emergency responders, OSHA requires you to evaluate them before you start work. Your rescue service must be able to respond in a timely manner, and timely depends entirely on the hazard. If it's a total lack of oxygen, timely means they're there and acting in 3 to 4 minutes. They must be equipped with atmospheric monitors, SCBA gear, and extraction tools specifically designed for your exact type of space. They need basic first aid and CPR training, and most importantly, they must physically practice simulated rescues in your representative spaces at least once every 12 months. A rescue plan written on a piece of paper in the trailer is completely useless if the team hasn't physically practiced doing it.
I want to leave you with this quote to think about. The most dangerous moment in any confined space operation is the emergency. When things are going well, it feels like just another day at work. But when a hazard spikes, panic becomes your worst enemy. Treating every single confined space with maximum respect and strictly, methodically following the permit procedures is the only way everyone makes it home to their families at the end of the shift. And that wraps up the dirt-level hidden hazards of our site. We've talked a lot about being trapped in the ground, but we know job site hazards don't just happen below us. I want you to stay grounded, take these lessons to heart, but keep looking up, because as we keep moving forward into our next topic, we are going to tackle the massive, swinging dangers of cranes and heavy equipment. Are you ready to see how a momentary lapse in focus can bring literal tons of steel crashing down on a job site? Let's keep moving.
All right, we just spent the last hour crawling around the tight, hidden, and frankly invisible dangers of confined spaces. Take a deep breath, shake it out, because now I need you to step out into the daylight, look up, and shift gears completely. We're moving out of those trenches and straight into the massive, open-air, high-stakes world of crane operations. This is a massive shift for us on the job site. With confined spaces, the hazards were restrictive, hidden, isolating. But with heavy equipment, the physical realities are entirely different. The hazards here are massive in scale, they're highly visible, and guys, they leave absolutely zero room for error. A mistake in a confined space often puts 1 or 2 lives at risk, which is an absolute tragedy. But a catastrophic crane failure, that can take out a dozen workers on the ground, destroy a multi-million-dollar project, and impact an entire city block in literally a matter of seconds. So let's look straight at OSHA Standard 29 CFR 1926.1400, Subpart CC. It clearly states the scope. This federal standard applies to power-operated equipment that can hoist, lower, and horizontally move a suspended load. What's really interesting here is how broad that definition actually is. We aren't just talking about some towering crawler crane that takes a week to assemble. No way. Whether it's an articulating knuckle boom crane, a tower crane over a high-rise, or a dedicated pile driver, if it hoists and moves a suspended load, you're playing by these strict federal rules. Let's start from the bottom up, literally. Before that boom ever extends into the sky, we gotta talk about ground setup and stability. I can tell you from over 15 years of walking job sites, tip-overs are a leading cause of catastrophic crane accidents and fatalities. And you know what? They almost always start right there in the dirt. You need firm, properly drained, and level support. You've got to use appropriate mats, blocking, or crane pads, and they have to be sized correctly for both the maximum load and the specific soil conditions you're sitting on. Here's a quick veteran pro tip for you. Notice that last point about the controlling entity? That means the prime contractor or the site owner holds the legal responsibility to ensure that ground is prepped and safe. An operator in the cab cannot magically fix a sinkhole with a crane pad. It's a site management responsibility.
Okay, so the ground under our tracks is solid. Now, I want you to think about something for a second. What is the most dangerous invisible overhead hazard on any construction site? Give it a thought. It's not a dropped load, though those are obviously terrible. It's electricity. We're talking about energized power lines. And this brings us to the most critical absolute life or death segment of this entire training masterclass, electrocution.
OSHA does not mess around when it comes to power lines. They give you exactly 3 strict legal options for safety when you're setting up heavy equipment. Option 1, de-energize and visibly ground the line. Option 2, maintain a 20-foot minimum clearance. Or Option 3, use Table A clearances, which you can only do if the exact working voltage is known. Listen to me carefully here. You must always assume a power line is fully energized and completely lethal until the utility company physically grounds it and explicitly tells you otherwise. Operating under that assumption is the only way you guarantee you and your crew go home alive tonight. Let's break these options down with a real job site cautionary tale. Say you're setting up a lift, and you call the utility company, but they tell you they simply cannot shut down the neighborhood grid today. Honestly, it happens all the time. That means option 1 is out the window. You are now legally bound to step 2 or 3. If you're operating anywhere near that clearance zone, a dedicated spotter is your absolute best insurance policy. That spotter's only job in the entire world for that shift is to stare at that boom and the power line and alert the operator before disaster strikes. All right, time to lock in a massive exam tip. 10 feet. I want to be very serious here. For lines up to 50 kilovolts, 10 feet is the absolute minimum safe approach distance. Burn this number into your memory right now. You will see this on the test for sure, but more importantly, you need to see this invisible 10-foot bubble every single time you look up on the job site. But what happens when the juice gets turned up on those lines? Let's walk through how this scales up the danger zone. As the voltage goes over 50 kilovolts, that standard 10-foot safety bubble just isn't enough anymore, because electricity of that magnitude can literally arc through the air and find ground through your crane. So for every additional kilovolts over 50, OSHA requires you to add another 0.4 inches of clearance.
The danger zone scales up fast, guys, and you absolutely have to do the math before the lift starts.
I really want you to absorb a crucial real job site scenario here. The rule states the 10-foot distance applies to every part of the crane and load at all times. On a windy day, the load can swing several feet from its intended path. Contractors get hit with massive, project-killing fines because they forget that wind pushes the load line. The boom tip might be 15 feet away, but if the wind blows the tag line and the suspended load, and that swing breaks the 10-foot barrier, bam, that is a severe federal violation. Even if it never actually touches the wire, you encroached on the death zone.
So, running heavy machinery safely is not just about the person sitting in the cab. That brings us to the crane safety team, your operators, riggers, and signal persons. This is a team sport through and through. I'm going to hit you with another massive exam tip here, highlighting the OSHA legal distinction between a competent person and a qualified person. This tricks people on the test all the time. A competent person is someone who can identify predictable hazards and has the authority to take prompt corrective measures. Basically, they can spot a danger and yell, "Stop work." A qualified person, on the other hand, possesses a recognized degree, certificate, or extensive knowledge to actually resolve subject matter problems. So think of it like this. The competent person stops the bad lift. The qualified person engineers the correct one.
Which brings us directly to the qualified signal person. This isn't just some guy waving his arms around, pointing where he wants to steel dropped. A qualified signal person must know standard hand signals, radio voice protocols, and crucially, they must have a basic understanding of crane dynamics. What does that mean? It means understanding swinging loads and boom deflection. When a crane picks up a massive load, that heavy steel boom physically bows and deflects downward. If the signal person misunderstands that deflection, the load swings out further than expected and can instantly crush a crew member against a wall. That's exactly why signal persons must be evaluated and documented by a third party or a qualified in-house evaluator.
Next up on the team is the qualified rigger. This is your rigging expert who successfully demonstrates the ability to inspect hardware, select the proper slings, and solve complex load angle lift calculations. The rigger's responsibility is absolutely immense. An improper sling selection or accidentally sideloading a hook because of a bad setup is a fast track to a dropped load. And let me assure you, a dropped load is a multi-million-dollar disaster that puts your company on the evening news and risks everyone's life. All right, let's shift our focus from the team back to the machinery itself. We're looking at equipment defenses and inspections, which is really all about catching failures before they happen.
Subpart CC demands rigorous inspection schedules because catastrophic hydraulic failures and worn, snapping wire ropes are the leading causes of equipment downtime and fatal drops. We've got to catch the wear and tear before the metal snaps. Let's dive into this timeline. Shift or daily inspections are visual checks done by a competent person, usually your operator doing their morning walk-around. Monthly inspections involve documented checks of the hook and hoist equipment. Then you have your periodic or annual thorough review, which must be done by a qualified person. And finally, post-assembly mandatory checks by the assembly/disassembly director. Walking around the rig, checking the anti-tube lock devices, and looking for weeping hydraulic hoses before firing up the engine, that is exactly what separates a seasoned professional operator from a dangerous amateur.
There's one number you must never forget regarding your work area: 360 degrees. This is the 360-degree rule. Work zones around heavy equipment must be physically marked or barricaded for the full 360-degree swing radius. When that crane superstructure rotates to move a load, the massive iron counterweight swings out blindly behind it. If you have workers walking through that zone without barricades to stop them, they will be struck and crushed by the counterweight. Barricade the radius, guys, no exceptions.
And this brings us to a final, incredibly practical warning for the job site. Rated capacities and load charts absolutely must be posted directly at the operator station, right there in the cab. Never ever let an operator simply guess their crane's capacity. Yeah, it feels like it can hold it. That is a phrase that precedes disasters. Those charts are highly complex engineering documents that factor in radii, boom length, and equipment configuration. Ignoring them or just not having them available to reference is exactly what causes catastrophic tipovers.
All right, team, look at that. You've officially survived the hazards of the job site walkthrough. You conquered the tight squeezes of confined spaces, and you've just mastered the heaviest, deadliest equipment on the construction site. But before we move on, ask yourself this. If a lift goes wrong tomorrow, will you be the one who spoke up or the one who assumed someone else checked the rigging? Gravity doesn't give second chances. Keep that in mind.
Now are you ready to lock in your OSHA 30 card? Grab your notes, stretch your legs, and don't lose this momentum, because we're heading smoothly and directly into our final destination. Final exam preparation and passing tips. Let's go get you certified. All right, folks, step on out of that confined space and take a massive breath of fresh air. We made it through our last session, and man, look where we are now. We are staring down the absolute final hurdle of this entire 30-hour masterclass. You've put in the time, you've done the heavy lifting, and you are literally right at the finish line. This is it, the final push. We're talking about getting that Department of Labor card in your wallet, and way more importantly, getting back out to the job site. Consider this session your personal playbook for beating test anxiety, conquering that final exam, and actually putting this training to work in the dirt. I've been doing this for over 15 years, and I promise you, you already have the knowledge you need to absolutely crush this thing. So let's lay out the logistics right up front. For the OSHA 30 exam, you're facing a 100-question multiple-choice test. That's the gatekeeper. That's what stands between you and your card. Now, I know 100 questions sounds like a lot. It's a big number. But remember, there are no trick essays here, no complicated math problems. It's really just a straightforward check of the safety concepts you and I have been covering together over the last 29 hours. And honestly, here's the best news. OSHA is not looking for absolute perfection. You don't need 100% to get your card. You just need a solid 70% to pass. What does that mean? It means if you understand the core concepts and just apply practical, working, common sense knowledge to these scenarios, you win the day. You only need 70 correct answers to walk away certified. But, and I need you to listen very closely to me right now, because this is a strict rule across the board. You get exactly 3 attempts to pass this exam. If you fail 3 times, you are permanently locked out of the system. Let me repeat that. Permanently locked out. That means you have to completely re-enroll, pay the fees again, and restart the entire 30-hour course from scratch. Yeah, no way. We definitely do not want that. So take a breath, don't rush it, and just use the knowledge you already have. Okay, let's dive into the material and see where you should really focus your energy. We're going to start right with the heavy hitters. You are going to see a ton of questions on the focus 4 hazards. We're talking falls, electrocution, struck by, and caught in or between. OSHA prioritizes these because, frankly, they cause the vast majority of construction fatalities. I've personally seen way too many sites shut down and too many lives changed forever because of these 4 hazards right here. Master the focus 4, and you are well on your way to that 70%. Now, let's talk about the ultimate trap question. The exam loves to test your knowledge on specific numbers, and this one right here illustrates a massive trip-up point. In the construction industry, the rule for fall protection generally kicks in at 6 feet, but in general industry, it kicks in at 4 feet. Read the exam question carefully. If it says you're on a construction site, lock in that 6-foot rule. Don't let them trick you. But wait, there is a very critical exception here, and I guarantee they're going to test you on it. If you are working on scaffolding, the fall protection requirement kicks in at 10 feet. Not 6, not 4, it's 10 feet. Write that number down right now. The test makers absolutely love specific numerical differences like this, so make sure you have these specific trigger heights locked in your memory bank. Moving on. As supervisors and safety leaders, you also need to know the hierarchy of controls like the back of your hand. When you get a question asking for the best or most effective way to handle a hazard, you always start at the top. Elimination. Just get rid of the hazard completely. If you can't, you move down to substitution, then engineering controls, and then administrative controls. The crucial point here, personal protective equipment, your hard hat, your safety glasses, that is always your absolute last line of defense.
Let's pivot over to test-taking strategy for a second. You've got the knowledge, right? But how do you beat the multiple choice format itself? First rule, read every single question twice. Seriously, I mean it. Watch out for absolute trap words like except, always, not, or most significant. These tiny words completely change the entire meaning of the scenario. A lot of guys get answers wrong, not because they don't know safety, but simply because they skimmed and misread the question. Let's run a simulated practice question right now just to get you warmed up. Here's your practice scenario. What is the minimum clearance distance between overhead power lines and a person? Think about it. I'll give you just a beat here to feel that exam pressure, and guess the answer in your head. Is it 4 feet, 6 feet, 8 feet? What about 10 feet? Bam! The answer is 10 feet.
lock this number in right now. Preventing electrocution from overhead power lines is a massive, massive priority for OSHA, and this specific distance is highly likely to appear on your test. If you see overhead power lines in a question, your brain should immediately just scream 10 feet. All right, let's throw a second practice question at you, and this one relies on that tricky, most significant wording we warned you about just a minute ago. Practice scenario. What is the most significant hazard in a trench? Is it falling objects? Is it hazardous atmospheres? Or is it cave-ins? And the correct answer is cave-ins. Now, what's really interesting about this is that falling objects and hazardous atmospheres are absolutely real, dangerous hazards in a trench. They are really bad news. But the question specifically asked for the most significant hazard. Cave-ins are overwhelmingly the most lethal, which makes it the correct exam choice. Always prioritize the highest fatality risk when you see that specific phrasing. Okay, let's look at administrative stuff. As folks taking this supervisor level OSHA 30 course, you're expected to know your administrative duties inside and out. Let's rapidly review those strict employer reporting timelines. If there's a workplace fatality, you have exactly 8 hours to report it to OSHA. If there's an inpatient hospitalization, an amputation, or the loss of an eye, you have 24 hours. These numbers are heavily tested, so burn them into your brain. 8 hours for a fatality, 24 for the rest. No exceptions. Let's talk about some practical study hacks to get you across the finish line. Whatever you do not try to cram this all in one night. Use spaced repetition. Study for 25 minutes, then step away for 5 minutes. Grab a coffee, stretch your legs. This prevents the mental fatigue that leads to careless mistakes on a 100-question test. Also, take handwritten notes. Science shows it helps you remember way better than typing. And during the exam itself, always eliminate the obviously wrong answers first. It dramatically improves your odds if you ever hit stuck. I also want to give you a really reliable mental playbook you can use on test day. If you sit down and totally freeze up, remember the SAFETY acronym to recall your major hazard recognition protocols. S is for struck by hazards. A is for appropriate PPE. F is for fall safety. E is for electrocution. T is for the 30-30-30 rule for lightning. And Y? That's for you, personal responsibility. Honestly, write this down on a piece of scratch paper the second you sit down for the test. It'll save you. All right, let's shift gears for a minute. I want to talk to you directly, leader to leader. Passing a multiple choice test is great, but it's not the actual goal of this masterclass. The job site reality is that it's not about that little piece of plastic you're going to slide into your wallet. The card gets you onto the site, sure, but the knowledge is what keeps you and your crew alive. Take these 30 hours of knowledge out of this training room and apply it directly in the dirt. Because here is the sobering reality, guys. OSHA investigated 826 worker deaths in 2024. 826 men and women who clocked in for a shift in the morning and never went home to their families that night. And you know the absolute hardest part of that statistic? Almost all of those deaths were entirely preventable. Preventable, with the exact hazard awareness we've been discussing over these last 30 hours. Right now, the most frequently cited OSHA violations are staring us right in the face. Number 1, fall protection, with over 6,800 violations. Number 2, hazard communication. Number 3, ladders. The exact concepts that are going to be tested on your final exam are the exact same hazards that are getting guys hurt and killed on sites right now, today. This isn't just a textbook theory. This is what's actually happening out there in our industry. So my challenge to you is this. Take what you've learned and apply it directly on the job site. Speak up when you see something wrong. If you see a frayed cord, an unprotected edge, a trench without a box, call it out. Protect your crew. Be the active, vocal safety leader that your team desperately needs. Because at the end of the day, the real test isn't multiple choice. The real test is making sure every single crew member goes home to their family tonight exactly the way they arrived this morning. That's the true weight of personal responsibility. It's about looking out for the men and women working beside you, trusting them, and earning their trust by keeping them safe day in and day out. You have the tools, you have the knowledge, now you just have to go past that exam and put it all to work. So I'm going to leave you with this final provocative question. When you step onto the site tomorrow, are you just going to be another worker with a card in your pocket, or will you be a leader who saves a life? Go crush that final exam, look out for each other, and stay safe out there.